Okay, the session is being recorded today. So today is our first class for Java. So let me share my screen and let me discuss what we are planning to cover for the Java session for the next 6 or 5 classes. So I shared my screen. I believe everyone can see my screen. Is there anyone can confirm me if you can see my screen or not? Just one person should be
Yes,
fine.
I see you. I see.
Okay, wonderful. You can see my screen. Let me open the chat window to my other monitor. Okay. All right. So this is our course outline. The course outline for Java is for core Java training session. We'll have 1, 2, 3, 4, and 5 classes. This is the plan that we have right now. But can we always have the same plan? From my last experience, previous experience, no. If you need more classes, we'll do it. So let's not worry about it right now. Let's worry about the content that we are going to cover. Let's work for those content that we have right now that we want to cover for Java. So today's session, we had a plan to we'll go through these topics. We'll have the introduction to programming language. We'll have some introduction to Java compiler, interpreter, bytecode. We'll do some hands-on coding, like very fast coding. I mean, writing, printing out a string called hello world. We will discuss about Java variable, Java data types, Java operators, some hands-on practice, and the questions. Now, the first question I want to ask to everyone: why do we need programming languages? Why? Why we need programming languages? What's the point of learning these programming languages? Did anyone think about it? Why we need to learn Java? Okay, I know the high-level thing is that we need to get the job. We need to get Selenium thing done. Okay, this is the requirements from the job. Like, people asking this quality, these requirements. We need to know Java programming, but forget about that requirements. Just think, what's the purpose of this programming language? Any programming language, what is the purpose?
The development of the softwares.
Okay, let me just see who is talking.
Salman.
Okay, Salman, tell me, why we need programming language?
For the development of the softwares, that's what I said, for creating websites and designing things.
Okay. All right. So, and those softwares, those apps and those softwares, if you need to create those apps and softwares, you need the programming languages. Fair enough. This is the high-level overviews. Anything deep down, anything that you can share with me? That why, if I ask the same again, if I ask you the question, why you need softwares? Why you need apps?
Computer is a binary. It only read 0 and 1, but if we need software to present the program. If Java or other program.
No. Yes, but don't go for binary right now. Like Salman said that we need programming language to develop softwares, right? In web applications, software, web applications, operating systems. We need it, or mobile apps, anything. But the question is that why we need those apps, those software, those operating systems? Why? Why cannot we live a life without those things?
Because
like we had I mean, this is a Microsoft Windows, right? And this is, I mean, and in the operating systems, I have this Microsoft Word. why I cannot, I mean, what's the purpose of this Microsoft Word, right? Why?
To ease
Or
the
maybe
life
any,
of a
yeah,
human being, because if we do with the hand or with the human mind, everything is impossible in this kind of life. These we are spending these days. It
exactly,
is
to
complicated
make our
for
life easy.
prediction and for exact to do everything, because calculations are very heavy and everything. That software can do it easily and quickly.
Exactly. So we'll do something, we'll program something that will be done automatically without human intervention,
Mhm.
or making our life very easy, right?
Yeah.
So this is how the softwares come into the pictures. And to build a software, you need a programming language.
Yeah.
Now, this is the software right now. The computers that you have, you have the operating systems. You might have Mac, you might have Windows, you might have Linux. You have some softwares, a lot of softwares you have. Everything you see is software. Now, how this, now underneath your computer, if you, I mean, it's like some electronic stuff out there too, right? Some mechanical stuff out there too, like there is a motherboard inside your computers. There is a hard drive. There is some processor. So how this software thing is working with this physical stuff, the hardware? Do we need hardware? Without hardware, can we run any software? Is it possible?
Without any hardware, we cannot run any software.
We can run any software, right? I mean, that doesn't make any sense, right?
Mhm.
Then how this software and how the hardware thing is coming? Think about the keyboard when you type in, right?
Mhm.
When I type in here, just anything, I'm saying the hello world, and you can see it. You can see it from your monitor, right? From the screen that you have right now, you can see it. Now I'm giving some input from my keyboard, and you can see it at your terminal or at your screen, laptop screen, computer screen. You can see it.
Yeah.
Now the input that I'm giving, and you can see the output. So you have some physical items in here, physical hardware in here, right, involved in here. And you have the software also who is showing you the output. If you am typing A from the keyboard, it's showing A there, right? If I'm typing B, it's showing B there. How is this thing happening? Of course, there is a software. So that means software has the capability to communicate with your hardware.
Yeah.
Correct?
Yeah.
So the point, when you type A, B, C, whatever from your keyboard, it sends out a signal. There is an internal software in your operating system that can read that signal and convert it to something that you can see as an A, you can see as a B or C, or any characters, right?
Mhm.
So your software can take the signal and convert it to something that is human readable through this Microsoft Word application. Okay? So that means your software and hardware, they're related. Without hardware, you cannot think of a software. And just a hardware, there is no software. How human can communicate, how human can process this kind of task through that hardware. It's not going to happen, right?
Yeah.
Even think about the calculator. If you want to like calculate something, human, like a very simple additions, 2 plus 3 is 5. You give in the instructions, you take the instruction from the keypad from the calculators, and do some calculators and do the calculations and display you the output, right?
Mhm.
You also have a computer over there too. The idea of computers over there too, right? So the computer, how it works, you have some physical component, you have some software component, you have some standard input, you also have some standard output. That you can see in my monitor right now, this is called terminal or laptop screen, whatever way you think, but I will call it terminal. you can see the standard output through your terminal. Why I'm calling it terminal? Because say I'm opening this command prompt, right? Are you familiar with this command prompt? This is called command prompt. Long time ago, when there was no windows like this, there was only this black screen, a command prompt. That was the only operating systems.
Yeah.
Now I can open, yes, the DOS mode, right?
Yeah.
I can open another command prompt, right? So how many terminal I have in here? 1, 2. I can open many terminals. So each terminal can show me the what? Show me the output, standard output. And I can give input from where? From my keyboard. Okay, something like this. I give some input, it gives me some output. So this input, output, all those things are managed by your operating system. It can handle those. It can handle those instructions, those requests that you are sending through your keyboard external input, and it can display you through the output. Now, operating system itself is a big software. Okay, it's a platform, and in this operating system, you can install other software. Okay, and they can share all the hardware resources. Now, what hardware resources you can have in your computer? You can have mouse, right? Very simple. Or you can have like a printer. You can also have like a webcam, right? So, or you can have like some laptop have the biometric input, right? You can log in through your thumb. You can scan it. You can log in. So you can also have the sound system, the graphical system. All the hardware component could be shared. And who will help you? The operating system to help you. But again, there is some communication going on between the hardware and the software. Without hardware, software is nothing. Without software, hardware is nothing. Right? Okay. Till now, any question?
It's good.
No, clear.
Okay, good. Anyone have watched the movie Matrix?
Yeah.
Yes.
Yes.
I'm
Yes,
sure
we
you
see.
did, right?
Yes.
So
All the version.
wonderful. All the versions, Matrix Revolution, Matrix Reloaded, right?
Yes.
Wonderful.
Yes.
So what happened to the Matrix Revolution at the end of the Matrix, the trilogy that we have? The Neo died, right? How did Neo die? Neo went to the what? To the machine city, right? The machine that hosting all the software. The Matrix itself is the operating system, the software. Now the agent Smith, he was the bad guy, right? He was a kind of virus. So he was a kind of software, right? And
Yes.
Machine City, it was the hardware. Software, hardware, they're all related. I'm just trying to give you some silly example anyway. But what I'm trying to tell you is machine and software, the hardware and software related. The hardware is nothing but a machine, right? And the software is related. How they understand each other. They're also talking to each other. Because any instructions you're giving through the machine, it gets processed, and then you see the output. Okay? How this thing happening? How machine and the software, they communicate. Very low level thinking is that. Very low level thinking is that they work through some signaling process. They signal to each other. Through the software, you give some signals to the machine, and machine can understand, because machine, the electronic part of the machine, it can only understand the signals. Okay, so there are a lot of algorithms, a lot of system out there. How that system can understand the digital input, and it can transform it to some analog input. Okay, why I'm saying digital and analog? When you're giving some input in here, say I'm saying CLS is basically clearing the terminal, right? Anything. If I say PWD, not PWD in here. So I'm saying that DRP Okay. I want to see what are the folders are there in this drive. Okay. So this, this is just input that I'm giving, right? So what exactly happening? I'm giving some digital input. It gets converted to some analog signals, and computer can understand, machine can understand the signals, right? So there would be something that machine can understand.
So what is digital signal you were saying? Digital signal, DIR?
No, it's just a command. This command gets converted in many different levels. Any command, any input you're giving, it gets converted in many different levels. So this command that I'm giving, saying the dir/p, is basically showing you some output. Okay. So what exactly happening? It gets converted. This command gets converted to something called bits.
It's a bits.
It's the bits. It's a binary number. So that means whatever the instructions you are giving in here, the use software, there is some software that convert it to something called binary definitions, a binary representation. Now let me open up something. Let me just give me 1 second. Okay, I found it. So look at in here. So when you give some instructions, right? Like this command, it get compiled. There is something in your operating system that convert it to something, and that get converted again at the end of the time is 1, 0, some zeros and ones. That means 0 and 1. It always gets converted to something called binary number, zeros and ones. These are called bit. 0 is a 1 bit, this is 1 bit, and this is another bit. This 2 is together is called binary numbers. 0 and 1 are binary numbers. The binary means 2. Any instruction that you give, it gets converted to binary numbers. Any instructions. And this binary number gets converted again to something, some electronic signals. So any instructions you're giving, it gets converted in many different levels. Okay? Anything that you do in your computer, in your software, anything you want to perform, it gets converted to 0 and 1, which are binary numbers, binary representations. And then this binary representation again gets converted to something, these signals. And this signal, machine can understand. That means if I say, if I like type it down in here, so anything you want to give instructions, it gets converted to something like this, some signals. This is the amplitude, right? This is the base. This is another base. This is another amplitude in here. Then, so what's happening here? So this is, hold on a second. This is 1. This is 0. This is 0. And this is also 0. This is 1. This is 1. This is 0. This is 0. So any instruction that you're giving through any software applications or through your programming languages, it gets converted first to this 1, these bits, these binary numbers. Computer do it. You don't have to think about it. How computer do it? Computer do it. So if I if I look into this representation, so this representation is something like 1 0 0 0 1 1 0 0. This representation get converted to some electronic signals which machine can understand. So that means use software application get converted first is to some binary numbers. So if I write it down here, first is instruction first get converted into some binary representation. Okay, the computer instruction. Okay, computer instruction first get converted into some binary representation. For example, maybe 0 1 0 1, anything. It could be 0 1. There could be like millions of zeros and ones, right? Then after that, binary representation get converted into some analog signals that machine can understand. Anyone have any question up to this point?
Why you say analog? Am I say it is a digital signal?
This is the analog because the representation is the electronic pulse, right? But can you say the electronic pulse are like a digital? How can you like represent it to some digital number? For instance, when the actual frequency happening, the actual frequency you can convert it to some digital number. We are converting to the digital number to some analog to the signals. When you say 1, the signals, the amplitude get high, right? When you say 0, then this is a flat. There is no wave is there, right? So that can never be a digital. I mean, you cannot digitalize that one, right? You cannot do.
That's good. That's good.
Right?
Okay.
This is why it can, because your machine. I mean, how machine will understand 0 and 1? It doesn't have any sense, right? But if you give the signal, if you send some signal, the machine can capture it, and the signal, then he can represent it. I mean, you basically converted your instruction to some binary number, and then you're taking this binary number and represent it to some analog signal that machine can understand.
Okay, understand.
Now, if you give these instructions, the way you're working right now in your computers, in your app, if you have to do it all by yourself, convert it to 0 1 and 0 1 instructions, you would never be able to use computer anymore. Because there will be millions of zeros and ones, you have to write it down. How are you going to do it? It's never possible. It's never going to happen. Also, let me give you another examples in here. See. So you giving signals to your machine can give a signal to you too, right? When I'm giving when I want to print something, is that I'm giving instruction to the printer, or printer giving instruction to me? I'm giving instruction to the printer. This is another computer system, right? And that can print something. At that time, my instruction get converted to some bits, and then that instruction also get converted to some signal. Now, if I'm giving input from my keyboard, what I'm doing, then I'm giving an input from my keyboard, from my hardware to the software. Say, I want to type it down something in here in the Microsoft Word. I'm giving input from my keyboard, and then the software can understand. Software can take that input software can take, only 1 second. Software can take that input and can represent this text. The thing that you can see here, computer, instruction, all the words that you can see it, how this thing gets printed. Because I'm giving input from keyboard. When I'm giving a keyboard from input, I'm giving some signals. The software can take these signals and represent it again bits, zeros and one, and those zeros and ones get converted to some digital number. So a lot of technical, a lot of electronic pulse working in here, and that get converted to some digital numbers. A lot of algorithm out there. The people who did electrical engineering course, I have 2 engineers in this class, electrical engineer, right? You might have familiar with some Manchester's coding, the binary representation, all those things, right? There's a lot of conversion, binary to analog, I mean analog to digital, digital to analog, analog to analog conversions. You guys have learned in electronics and electrical class, right?
Yes, Bhai.
Yeah.
You guys did it, and this is must. They must have taught you, you guys, and they also taught you all those different kind of logical gate too, right?
Yeah, digital logic design.
Okay, exactly. So this is the same thing, and this is a very core thing of learning. I mean, I'm just giving you this information so that you will get the most ideas in the futures. We're going to use these ideas, and the purpose of the learning programming language, it will be clear. Okay. So when you're giving input through your keyboard, it gets converted. It converts the analog signal to 1, 0, 1, 1 or something, some zeros and 1. And these zeros and 1 also get converted to some number. So this binary number can be converted to some decimal number. Binary number also could be converted to some other number system. There is some number system called octal. There's a number system called hexadecimal. So everything in computer is all about numbers. And these numbers represented in some text form, in some graphical input form, in some picture form. Anything you can see is just numbers. And that converted to something else. Computer is compute. It works all about the numbers. Okay. Now, if this is how software and hardware works, software sends some instruction, get converted to some machine languages, and then the machine languages get converted to some electronic pulse. And again, when you give input from a hardware, it also gets converted to some machine language, or I mean, then it gets converted to some digital input. So when we are working in a computer, in an application, do we know how this thing happens? How this thing happens? Do we even care about it? No, we don't care about it. But there is something sitting in between my software to get converted to some machine language or some electronic pulse. There are some other applications, other softwares are there who are responsible to do it. This other piece of information is called compiler or interpreter. Compiler or interpreter. That means when you give some instructions through your computers, it get converted to machine language or electronic pulse through these softwares. It actually does not change it to electronic pulse. It changes to some machine language. Now 010101, this is called machine language. Okay, these are machine languages. These are the very low-level language. For any human to write down these instructions, write down any instruction in the 0101 format is absurd, right? That's not going to happen. How big this instruction might look like, just to print out a single line, it might require some thousands or, I don't know, millions of zeros and ones. How long it will take for you to write it down? You cannot do it, right? But there's something the programming language can do. First thing, programming language can take you, programming language can change the instruction. Take the instructions, okay? Then convert that instruction to something that machine can understand and do the further processing, right? So any programming language that you can see right now, it might be C, C++, Java, Python, Perl, Groovy, Scala, any programming language. They all do the same thing. They take the instruction, you giving the instruction through the programming language. Now every programming language has a different way of writing the instructions. When you are saying coding, what you're doing through the coding, we are write down some instructions following the syntax for that programming language. Now syntax means what? Syntax means rule. Syntax is some specific rule to some specific programming language. The way C programming language is written is not the same that C++ is written. The way C++ programming language is written, the code is written in the C++ programming language, it's not same the way programming coding is written by the Java programming language. They all have their own rules or syntax. Following the syntax, you are actually giving some instruction to your computers to do some work for you. And when you're giving the instruction, that instruction again gets compiled or again get changed to something that machine can understand, which is 0, 1, 0, 1, 0, 1 or something like this. Zeros, lot of zeros, lot of ones. And those zeros and ones again get converted to some analog signals that your computer, your actual hardware can understand, right? So this can happen vice versa. Software can send the instruction to the hardware, hardware can send instruction to the software, and they can understand and they can do the communications. Now, programming language can help us to process those instructions through the computer system. This is why we have different programming language. And why we have different programming language is programming language have each kind of benefit, each kind of different syntax. They can work at different level. When I'm saying different levels, what are the different level of programming languages we can have? Levels of programming languages. So we have low-level programming language. We also have, sometimes they call high-level programming language. In between low-level and high-level, they sometimes call another kind of programming language. They call mid-level programming language. So what is low-level programming language? It's something sitting all the way end of the instructions. Like machine language is a low-level machine language or low-level programming language. So if I say so machine language, or they also call assembly language. Assembly language, they are low-level language. Let me give you some examples of machine language. You see in the right side, it's saying some command. It looks like some command, right? Push, move, pop. This right side, whatever you see in the right side, in here, these are the example of machine language or assembly language. They are very hard to coding, very hard to type in and write it down. Okay, they are not close to the human language. will you understand anything from here? No, it's very hard to understand. Now, similarly, if you go to the left side, okay, this is the example of some high-level language or mid-level language, right? This is a C code. This is a C programming language code. C programming language code sometimes called mid-level or low-level. Some people, sometimes called mid-level or high-level. Okay. So the C, C++, Java, they are called high-level language. So if I give you an example, so C, C++, Java, Python, these are all high-level languages. Why they are called high-level languages? Because they are almost close to the way that humans communicate with each other. The instruction that is given is human readable, human can understand, human can have an idea that what's going on. Okay. There are some like instructions say print, and it will just print something in your standard output. Okay. So there are some instructions, there are some languages who are close to the human language, and there are not that much of effort that you have to put, like the way you are writing the assembly language. The kind of effort that you will be putting writing the code, see how many lines in here, 1, 2, 3, 4, 5, 6, 7, right? And how many lines are there in here. So this piece of instruction need how many lines, and this piece of instruction need how many lines. So this is the high-level language which is more efficient than writing code in assembly or machine-level language. This is why these programming languages are more popular than this assembly language or low-level programming languages. So when we are learning Java, Java is a high-level programming languages. Any questions so far? Okay. No question. Okay. All right. So we have so far we discussed that programming languages can take the instructions, and those instructions get converted to something that machine can understand. And what machine can understand? Machine can understand some electronic pulse or signals. So when programming language is converted to some instruction, it actually first get converted to some zeros and ones, and those zeros and ones get converted to again some electronic pulse. So this is how programming language works. This is how the instruction gets processed through the computer systems. We have different kind of programming languages. These are levels of programming languages. Low-level programming languages. We also have high-level programming languages. Low-level programming languages, examples are machine language or assembly languages, which are very hard to write it down and get converted, and then they get converted to machine language. The assembly languages get converted to machine language very fast because they are very much close to the machine language. They are very much close to the machine, right? Now, the high-level programming languages are something which are very useful to understand. They are very much close to the human, like the human communicate through the different languages. So this is high-level programming languages. But this, whatever instructions we give through these programming languages, they get again converted to something called bits and bytes, like bits. This is always happening, no matter what programming language you choose. Java is also called high-level programming languages.
Can you explain again the compiler?
The compiler?
Yeah, the compiler. What was the purpose of that? I missed something.
Yes. Compiler, I'm going to explain again. This is something that I need to understand very well. So compiler. So what is the purpose of compiler? Whenever you give some instructions from your programming language, right? Then compiler will convert that instruction to some binary representation.
Okay.
say I'm saying system dot out I'm just writing some simple code from Java saying that hello world. Okay, and the output that you can see from your terminal, okay, from your console output would be hello world, right? So what is happening here when you're giving instruction from the programming language where you're writing this code, and then you can see the output hello world. This is a very simple example I'm giving. How compiler working in here? First thing will be happening whenever you're writing any code, right? The code is called source code. This is your source code, right? Then this source code, Java has its compiler. It's called Java compiler. And your source code will have the extension with .java. Say our file name, we are saving this code in a file. Our file name is my Java, and the extension should be .java. We have written some code, and we are saving. Again, I'm going to show this thing in a practical, in hands-on coding, but giving a high-level overview first. We have written this code in some file, and we are saving this file with the extension .java. This is my source code. Why I'm calling it source code? Because this file will have all the coding, the actual coding, which are written in Java. Then Java compiler come into the pictures. Let me just, Java compiler come into the pictures. And what does the Java compiler do? Java compiler will take this instruction. This is a statement, Java statement, right? And the instruction basically saying, hey, print out this hello world, this string. The meaning of the string is the number of words. When you have number of words in a sentence, we call them a string. We are printing these words, and this word has been printed. How this word get printed? This source code taken by the Java compiler convert this source code to something else, which is called bytecode. Now this bytecode will have the same file name. It will create another file, but it will have the extension with class. Okay. So Java compiler is converting this source code, actual code, to something called bytecode. Now this bytecode, who understands this bytecode is Java virtual machine. Java virtual machine understands this bytecode. Okay. So up to this point, Java compiler, so compiler can convert a source code to something that machine can understand. Okay. So you have written some code, machine should understand the instructions. Compiler is helping you to convert that code that you have written to something that machine can understand. Let me give you some examples. Just hang on with me. Say this is common prompt. You guys can see the screen, right? This is a Linux operating system. This is a virtual computer. So if I open up this code, let me do one thing. I know it's a very small test, but try to understand. This is the code written in C programming language. And what I'm trying to achieve from this code, I'm trying to print out something, some string called hello world. Okay, very simple. I just want to print it. So this code is written in a file. I save it in a file. The file, this is my source code. This is my source code. Okay, this is my source code. Now, my source code needs to be compiled. If I don't compile, I cannot execute this file and it will never print out hello world. I need to compile something that machine can understand. So there's a specific code that I'm going, this specific instruction, specific command that I'm going to use. Okay. So when I type this command, so there is another file is created. See the green color world. This is my compiled code. My actual code was world.c. If I see world.c, this is my actual code, right? But what if I want to see the compiled after I running the after I execute the GCC, after I executed this command, actually the world.c, this source code get compiled to something, to this one, world, the green color file, world. This is another file. So this is the file. If I execute this file, then machine will understand. Now this file, if I look into this file, it will look like this. It will look like this. Some characters, I mean, these are represented by zeros and ones. You will never understand. You don't have to understand, but it gets converted to something the machine can understand. So why I need this? Because I cannot run my source code directly that machine can understand. I have to convert it to something, to some other file. My compiler, the compiler, C programming compiler here, helping me to compile, to change the actual source code to something the machine will understand. Now, if I execute this file, see, it's printing me what? Hello world. I'm printing this file. See the all those numbers that you don't understand. I'm just executing this file, and then it printing me hello world. Just don't get stressed that how this code is written, how this thing happen. Only thing here to understand is that you have your code written in some programming languages. It gets converted by your compiler to some other file that your machine can understand. And when you execute that file, then you can achieve what you want to achieve, right? What you want to have. I wanted to print hello world. Okay. I was able to print hello world after executing the file which is already converted by the compiler. This is what compiler do. Compiler will take your source code and convert it to some other file or other instruction that your machine can understand. This is a very simple term of compiler. So if I write it down, what compiler can do? Compiler can take the instruction written in some programming.
Can you lower the screen? I can't see the top.
What was that?
I can't see the top of the screen for some reason. I can't see what you're writing because it's going on. Thank you. Yes.
You can. Okay, fine. Compiler can take the instruction written in some programming language and convert it to some other file. This is important. To some other file. This is a very important thing to understand. It will convert it to some other file that you or your computer can execute to achieve. Computer can execute and the machine would understand to produce any update. Okay, to produce or to display any update, to display output actually, to display output. Okay, so what is compiler? Compiler can take the instruction written in some programming language and convert it to some other file that sometimes you can execute or your computer can also execute automatically, right? Can execute and your machine would understand to display any output. Okay. So the way it is working in here for C programming language, for example, the example that I show you is a C programming language. So I have my source code, okay, and my source code get compiled. Then I have some compiled code, and then my compiled code get executed. Then I have the output, isn't it? So I had the world is the green color file. Let me remove it again and do it again. I'm just giving the example from this platform. We don't need to learn C, you don't need to understand, you just need to understand how it's working. Then this understanding I can put again to the Java, okay? So I have this, now I have only the source code. This is my source code, okay? I'm going to compile it. What is my next step? Can someone read it down? What is my next step after source code? It's compiled, right? I need to compile the code. So this will be compiler. Okay. So what I'm going to do, I'm going to execute this command. This command. The option O means output. The output file will have the name world, or I can have any name. Okay, any name, any name. Okay. And what I'm going to compile, I'm going to compile this file. Okay. Now, if I execute this command, what will happen? The compiler will come into the picture, and it will execute, and it will create another file, right? So compiler come into the picture, I execute through the compiler, and I am getting another compiler code or compiler file, right? It will be another compiler code. I mean, definitely you will have a file that will have all the code, right? Otherwise, how you can have your code? So if you come in here, so another file is created, which is the name I've given is any name. Okay. Okay. What is the next step? Next step is that when you already have a compiled file, you can execute that file. Okay. You can execute that file. Execute that compiled file. Compile code or file. Compile code or file. You can execute the compiled code and file. So if I execute the compiled code and file, this is the command that is used in C, for C. So see, when I execute the compiled file, then I get the output. What is the output? I wanted to print out hello world, and I get the output hello world. The compiler basically takes the instruction written in some programming language. Then after that, then the compiler, this compiler can convert the source code to some compiled code or file. And you have this file right now. Now, if you execute this file, then you'll get the output. You cannot execute source code right away, and you are not going to get an output. That's not going to happen. You need to convert it to something that machine can understand. Okay. Again, when you executing this file, when you're executing this compiled file, what happened? It again get converted to something. It again get converted to something like I told you, electronic pulse, right? This is the very low-level thing that you don't have to worry about it. Your operating system or the compiler, it will take care of it. But you need to understand that if you don't compile, that you will not get a compiled file. This is important. You need to get the compiled file. If you don't get a compiled file, you cannot execute your program, and you will not get an output.
Quick question.
High level, yes.
I'm sorry. What is the process of executing it? Like, is that another step, or just hitting enter? How are you executing this file?
So this is when I'm saying executing this compiled code, for different programming languages have different way to execute the compiled code, right?
Okay.
Now for C programming language, I'm just giving you the example. I'm just telling you that it's a generic term that you need to execute. In C programming language, how I'm executing? Like this. I'm giving dot, front slash, I'm giving the name of the compiled file. I'm pressing enter, I'm getting the output.
Got it.
For Java, it might not be the same.
Mm-hmm.
Java, it will be different thing.
Okay.
Java, it will be a different thing. Now, if I have to write Java code in here, I can do it and I'll show you. It will be a different thing. But the idea is same, right? The similar idea. You need to convert it, then you need to execute it. Now, how you going to execute it? It's different programming languages, different way to do it. That programming language is specific question, right? But in a general term, you need to execute you compile version code, then you can get something displayed in your output.
Okay.
You're getting my point, right?
Yes.
So this is how compiler works. This is how every programming language have the concept of compile.
Okay.
This is converting your source code to something that machine can understand. It's like you are talking with me. Say if you can speak Spanish, for example, right?
Mm-hmm.
And if I can speak Bengali or any other form of language. Now, if I want to talk with you, if we want to have some discussion and we don't know English, how are we going to have the communication? We need someone else. So maybe someone else is someone else is your friend from this class, Lisa.
Yes. Yes.
So I'm talking with Emily. Juel is talking with Emily, but Emily does not know Bengali, and I don't know Spanish. But Lisa can understand Spanish. Lisa can understand English. And Lisa can also Lisa understand Spanish and Bengali both. Only these two, right? So I'm telling Lisa, hey Lisa, tell Emily how is she doing today.
Mm-hmm.
Then she can take the instruction, she can change it to Spanish, right? And she can ask you, ¿Cómo estás?
Yes.
¿Cómo estás, Emily? Then Emily returned back saying, muy bien, right? I don't understand muy bien. Lisa can understand. And Lisa can convert it. Lisa can say, hey, she's doing fine.
Right.
So this is how the compiler coming into the picture. Compiler is sitting between the source, between your source code, your actual instruction that machine will not understand right way.
Right.
Compiler is sitting between your source code and your machine, the machine that will process the instruction, right?
Okay.
So compiler will convert it to something that you can execute and machine can understand. A lot of other things can happen in different levels. The signal process, the conversion of analog code to the conversion of digital instruction to some analog signals. A lot of things can happen underneath. I mean, behind the scene, right? That we don't know. We don't worry about it. But we need to know that this is happening. It's not happening right way. It's not like that. You give the instruction. It's just taking your instructions and processing it right away. No, a lot of other things are involved in here. So when you're writing your code, it get compiled and it get converted to something 0, 1, 0, 1, 0, 1. Maybe millions of zeros and ones are there, and that signal, that digital 0 and 1 is digits, right? There are some digits. They are some digital. They are not analog. The zeros and ones get converted to some analog signals that your machine can understand. Now, we need compiler, very useful. Compiler is very useful. Every programming language has compiler. Every operating system has compiler that can take the instructions and process it something the machine can understand. Now, compiler can take the source code and create another file, which is called compiled file. In this example, the compiled file that I have created is called any name. I gave the name, any name. It could be any name. Or if I remove it, any name, I can just say something, say compiled file. Okay? This is my compiled file. See, this is compiled file. It should be compiled. I say compiled file. Okay, anyway, it should be compiled file. Okay, so this is the file which get converted by the help of compiler. So if we execute this file, your machine will understand. Anyone have any more questions to understand why we need compiler, how compiler works, and what is the purpose of compiler?
Do you mind if we take a 10-minute break?
So she takes some break.
Yeah, we need to take a 10-minute break. Do you mind?
Oh, it's 4:30, right?
Yeah, can we run the computers?
Okay, so let's do one thing. Let's take a break for like take a break for 10 minutes.
Thank you.
And let's come back at 4:45.
Thank you so much. I have to grab a coffee.
Okay. Rest of the guys, let's take a break and come back with some questions up to this much that I covered for compiler. Okay.
Okay. Okay. Yeah.
Okay then.
Okay, Juel bhai.
Okay, let me thank you. Okay, it's recording again. Thank you so much. All right. So yeah, the class was no recording. Sorry about it. Now I recorded it again. I just marked it. I just paused at the time. Now if this is compiler work, similar to compiler, there is another thing is there. Like I gave you the example, right? The example between me, Emily, and Lisa. Now there is another thing that there is another concept is that is called interpreter. Okay. So what does a language interpreter do? The same thing that I gave the example between me, Emily, and Lisa, right? Say the president of the United States going to have some meeting with president in North Korea, for example. Now the president from North Korea, he does not speak English, right? And the president in United States, he even does not speak in North Korean language, whatever it is, he doesn't speak it, right? So if they have to communicate between each other, there need to be someone who can interpret their languages, right? So in this way, they can communicate. So that person is called interpreter, okay? That person is called interpreter. Give me 1 second. Whoever is not talking, could you please mute yourself? Okay, I just mute everyone. Okay, thank you. All right. So compiler is a kind of interpreter, but compiler has some way of working this interpreting and how it's interpreting, right? So that means if I think Lisa is a compiler and I am as a source code and Emily is a machine, right? I'm just giving an example. So how compiler work is that I have to say whatever I have to say everything to Lisa. Lisa will take all the input from me and she's probably going to write it down, or maybe I have written something, I'm giving it to Lisa. I'm saying, hey Lisa, could you please convert it to something that Emily can understand? Lisa will take the input and whatever I have written down, Lisa will convert it to some language that Emily can understand, and it will create another file. Okay? It will create another file, and that file is written in some language that Emily can understand. And Lisa will give that file to Emily. Emily will look into that file and Emily will say, okay, now I understand what Juel is saying. Now let me reply back. Now Lisa will understand and Lisa will reply back the answer, whatever the answer she has, or whatever the discussion, whatever the thing that I asked her to do, she will do it, right? Maybe I'm asking Lisa to help me with something, so I'll write it down, and Lisa will convert it to some language that Emily can understand, and give it to Emily. So all the instructions I'm giving all at a time, all together. So it's not like that I'm giving some instruction to Lisa taking it and then coming back to me for the next instruction. No, all the instructions I put and I have written down in one single place, and I'm giving it to Lisa, and Lisa convert it to some other file, and then Emily is going to execute, or Emily is going to do something, do some work. This is how compiler working, right? Because if you look into this, if you look into the like a file that I shared, right? So what happened? All my code is written in this file, and then whatever instructions I will give in this file, it will get converted to another file, which is called compile file, right? So it's basically taking all the instructions written in one single file and creating another file that has all the instructions from the source file, source code. Okay, this is how compiler works. Now there is another concept which is called interpreter. How does that interpreter different than compiler? Interpreter will do the same thing. It will take the source code and it will convert to something that machine can understand. It will convert to something that machine can understand. The way interpreter work is that interpreter will take the instruction, it will read every single line and execute it right away. That means if I say Lisa, hey Lisa, tell Emily how she's doing. Lisa will go back to Emily and ask Emily, hey, Juel asked you how you're doing. And Emily will reply back and I will get the reply back from the Lisa. Then I will ask again the next question to Lisa, next question to Emily through Lisa, right? I'll say Lisa, hey Lisa, could you please tell Emily to complete her homework, or let me know if she completed her homework or not. Then Lisa will go back to Emily and ask the same question, and she will get the answer and give it to me. That means every single thing, every instruction that I'm giving, Lisa is going to interpret it and give it back to Emily, and Emily is replying back and I'm getting the output. This is how interpreter will work. Interpreter will take every single instruction from the source code and execute it right away. It's not going to create another file like the way compiler do. Compiler will look into the source code and compile and create a different file. And you can execute this different file to get the output. But interpreter will not do it. Interpreter will take the source code and execute every single statement, every single instruction that you have written inside your source code and execute it. It does not need a separate file. It's happening right away. Any questions anyone have to understand compiler and interpreter right now?
So the compiler and interpreter behave differently.
They behave differently, but they're doing the same task.
Same job, but they haven't.
Same job they're doing. What we want to give some instruction through our programming language, and it should be executed to get some output. Correct?
Mm-hmm.
To get it done, compiler and interpreter doing the same thing, but the way they're doing is different. Compiler is creating a separate file, and you execute that file, you get the output. For interpreter, you are not getting any separate file. It's basically going through every single statement or every single line written in the code and executing it right away.
So when we use compiler, when we use interpreter?
Exactly, I was going to say same thing. Thank you.
It's not like how when we want. It's like how the programming language behaves. There are some programming languages, they have only compiler, like C, C++. They only have compiler. The way they convert the code that machine can understand, to achieve this goal, they are using compiler. There are some other programming languages called Perl. They use interpreter. Okay. There could be other programming languages too. They use only interpreter because they don't need to use compiler. They think that they don't need to create another extra file. Okay. They have the interpreter. Interpreter will look into the code and execute it right away. This depends on the programming languages. Did I answer your question? It's
Yes.
not like when I want. It's not on me. It's like how a programming language behaves. Okay. If you're writing programming language in C, like the way I give you the examples in here, this is compiler. Now, if I write a programming language in Perl, that will be interpreter. Now, you can ask me the next question. Is there any programming language they use both compiler and interpreter? Yes. This is our Java. Java use both compiler and interpreter. To understand how Java works is very important. This is a question they ask many times during interview time, because they want to understand how much you know Java, how much you're familiar with Java, how Java works. Basic things you don't understand, moving forward, a lot of questions will be coming in your mind. It will not be clear. The basics should be very clear. If you want to learn Java, know Java from the very basic, from the very root. Okay. and how Java behaves, how Java works, we need to understand these things. Now, Java uses both compiler and interpreter. Now, the next question comes, if compiler can convert a source code to something that machine can understand, and interpreter can do the same thing, then why Java needs both compiler and interpreter? Is that a valid question? Yes.
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 Why? Why I'm using both of the functionality? Okay, why I'm doing it?
Because Java is in kind of language. Probably Java is better than the rest, I would say.
I mean, not like that. This is, I mean, the way Java design is that it requires both compiler and interpreter, because Java call itself is a machine independent language. What does that mean? That means, see, the program that I have written in here, and I compile the code, right? I cannot take this code to another system, to Windows Open. This is Linux. I cannot take it to Mac. I cannot take it to, maybe I can take it Mac, I guess, but I cannot take it to Windows to execute it. Why? Because this language is machine dependent. Machine dependent means it takes all other things from this machine specific stuff and then execute it. To execute this code, you should have the Linux systems. You cannot use Windows. You cannot execute the code in Windows. You cannot execute this code means if you want to execute this code in Windows, you need to compile it again. So this file called compiled file, right? You see that file, compiled file, the green color file. You cannot take this file and execute it in another programming language, another operating system. For example, in Windows. The file that is compiled, this is all related to this operating system. You cannot do it. This is machine dependent. This file is machine dependent. But what Java is saying, when you write a Java code and you compile the Java code, then that compiled version of Java code could be used to any operating system. This is why it's called machine independent. That means I can write a Java code in Mac, or I can write a Java code in Linux, and I can execute that compiled code to any other operating system. This is one thing, okay? To achieve the machine independency, Java has the concept of compiler and interpreter both. And how this machine independency work in Java? Using this simple diagram, I can explain it to you. Now, this is totally Java related. This diagram is Java related diagram. This is the Java related, how Java works. This diagram is telling you this. Now, you know, I told the source code, right? The source code, Java source code should have an extension called .java. Any file name, but file name should have the extension .java. Now, when you have this source code, you can compile it with Java compiler. Here, the way I did it, I compiled this code using C compiler, C programming language compiler, right? If I use Java programming language compiler, I can call it Java compiler. Java compiler will compile. Compile means it will take this source code and change it to another file. That file will have an extension called class, .class. It will change to something called .class. Java compiler will handle those things. You don't have to worry about it. If you compile some Java code which has the extension Java, it will get compiled to it will create another file called .class. Because we know the how compiler works. This is the general item. This is the general behavior of any compiler. Compiler will take any source code and create another file, another compiled file. So Java compiler is nothing different than that concept. Java compiler will take the Java source code and compile it to another file. That file has a special name. It's called bytecode. That file has a special name called bytecode. And that file must have an extension called .class. The name of the file is the same, but the extension here, source code have the extension .java, but bytecode have the extension is, bytecode is the compiled source code, Java source code, has the extension is .class. This is platform independent. Up to this point, we are calling platform independent. That means you can do it to any operating system and take this bytecode and execute to other operating system. You can do it. Up to this point is machine independent. Any operating system you can do it, and you can use this bytecode to any other operating system. Okay. Now another concept is there in Java, which basically you need it to say this. The Java is a totally machine independent or platform independent programming language. The another concept is called Java virtual machine. Now see the example in here. Here C programming language, when I created this compile file, right? This is the compile file. C compiler. I use the C compiler to convert this source code to a compiled file. Now this compiled file I can execute only in Linux, right? And this compiled file is I can execute for this computer system, for this machine. Now every machine, there might be some different architectures, right? Different kind of architecture. Some machine is called 32-bit system, some machine is 64-bit, right? So they have different processors, different processor versions. Some architectures are different. Not all computers have the same hardware architectures, right? So this compiled file could be executed for this computer system. It may not be executed to another computer system. Now my computer is a 64-bit computer. It can 64-bit computer. Now maybe I cannot execute this file to another computer that has 32-bit computer system, 32-bit operating systems. I might not be able to execute it. Even if it is Linux, I might not be able to execute it. So this is very much machine independent, this compiled file, right? So that means compiled file is always machine independent. So it's a machine dependent. Now in Java, when a compiled file is created, a bytecode is created, you can execute this bytecode to something different, something else, which is only Java specific. This is called Java virtual machine. Java virtual machine. It's a machine written through the software. This machine can take the resources that a physical machine can have, but this is a virtual machine. This virtual machine can take this bytecode. It can understand this bytecode. Okay. What compiler do? Compiler take the source code, convert it to something that machine can understand. Now we have this file. Now for which machine this file is created? This file is created for Java virtual machine. That means Java virtual machine can understand this bytecode, this compile code. So this Java compiler is converting it to something. Okay. Anyway. So the Java compiler is converting a source code to something that machine can understand. So this is a compiled file. In Java, it has a specific name, a special name, which is called bytecode. And also, this bytecode is for a specific machine. This machine is called Java virtual machine. It's not like the regular machine. It's a virtual machine. Now, this virtual machine is machine platform dependent. Now, this virtual machine that you have for Mac is different than the one that I have for Windows. It's also different than the one that I have for Linux. Also, for 32-bit system, there is a different virtual machine than what we have for 64-bit system. So this is machine dependent, Java virtual machine. Now, every product, I mean, Java, you might have seen that your phone has a Java update. Every computer system, they have something called Java. Java virtual machine already there. There are a lot of devices, physical devices are there. They already have Java virtual machine. So why Why they have already have Java virtual machine? Because they can take any bytecode which is generated to any other operating system and they can execute right away. So this Java virtual machine could be, Java virtual machine is platform independent, but it can read any bytecode or any compiled code which is generated to any other operating system. It doesn't matter. It doesn't matter in which operating system this bytecode was generated, but Java virtual machine can read it. So when Java virtual machine can read it, again, it takes the instructions and convert it to something that the actual machine, the actual hardware can understand. Now here, in this phase here, interpreter works. Here is the compiler, here is the interpreter. So I'm sorry, I don't have that whiteboard yet. I ordered it, but it's coming late, then I would have to write it down or type it down more better way. Probably next class onwards, I'll be able to do it. But for this class, I'm using the painting, this Java, the Microsoft Paint. So what I'm saying is, so here is your source code. This is your source code. Now, this is your source code. Then after this source code, sorry. Then what will be this one? Who can tell me? What are we gonna do in source code in here?
Compile.
We'll compile. We'll compile this source code. Once we compile this source code, then what we are going to get?
Bytecode.
We're going to get bytecode. So bytecode. This is, we are compiling source code and we are getting bytecode. So this is a compiled code. This is a compiled code, right? We can say this is a compiled file. We get a compiled file, right? I mean, whatever the file we are compiling, after that, whatever file we are getting, we call it has been compiled. So this is called, we have the bytecode here. Now, after this bytecode, what's the next thing happening? Now, this is the interesting thing. The next thing is happening is
Java
JVM. Java virtual machine, exactly. Now we have Java virtual machine. Now what Java virtual machine will do? In Java virtual machine have so many other components. What Java virtual machine do? Java virtual machine will load your actual code. Java virtual machine will allocate some memory. Anything that we work in this computer, we have a different kind of memory, right? Is there anyone know what are the different kind of, two different kind of memories in the basic level that we have in a computer system? I mean the two different kind of storage system that we have. We have primary memory and secondary memory, right? Primary memory and secondary memory. Secondary memory is your hard drive. And primary memory is your RAM, random access memory. So when we are working, anything that we are working in here, we are basically taking it from the secondary memory and working in the primary memory. Primary memory can be reduced, it can be, I mean, see, if I show you the system, I show you like this. See, this is the task manager. So see, I have primary, this is the memory. What is the memory utilization here? If I give the performance, where is the memory? Here's the memory, okay? See, I have in use 9.2 GB, right? I have available 6.6 GB. So I have so many applications running. If I close them, then I will have more memory which are free to use. That means primary memory could be reusable. It is dynamic, it gets changed, okay? More application I will be opening, it will be occupied by more application. If I close down some application, if I close this application, then you will see that I will have more memory available. So primary memory is a dynamic memory, right? So Java, so why I'm saying this, when you want to execute your programming language, then this programming language would be executed in your memory, in your private memory. And within the primary memory, Java virtual machine will create some other memory specific stuff that it needs to execute the code, right? It will load the Java file. It will allocate some memory for methods, for the variables, okay? And then it will execute, okay? It will also verify the code. All these things should be done by the Java virtual machine. Also, there is another specific thing about Java virtual machine is that it will do the execution. It will do the execution of this bytecode. And when it will do the execution of this bytecode, at that time, Java interpreter come into the pictures. Java interpreter, okay? So Java virtual machine can do so many stuff. It understands the bytecode, and when you want to execute your code, it will load the code in the memory. It will allocate some memory for the instance. It will allocate some memory for the methods and lots of other things that we'll learn in future. It will take care of everything. Also, it will also take care of the verification of the code. If code is right or wrong, if there is some error is there or not, right? If there is something problem happening, then I mean this is basically a runtime thing. That means when we want to run your Java, right? When you want to run your Java, then this thing comes into the pictures.
Joel, I have a quick question.
Yes.
Can we say JVM help Java code to run in any platform?
JVM is platform dependent.
Okay.
The JVM that is installed in Linux, the JVM that is installed in your phone, JVM that is installed in Windows system, JVM that is installed in any computer system, is that computer or that system specific. But when you are installing JVM for any computer specific, it becomes this computer specific, correct, right, Omiko? But that JVM can understand any bytecode which is actually developed and executed in another operating system. That can understand. That means I have a bytecode created in Windows system. You have a Mac, right?
Yes.
So JVM that you have for Mac is different than the one that I have for my Windows system. But your JVM can understand this bytecode which is generated in my Windows system, and you will be able to execute it.
All right.
Make sense?
Yes, sir.
Okay.
Thank you.
So yeah, so JVM will do so many other stuff. There's so many, like I said, that I already said, memory allocations, the code verification, so loading the class, allocation of the memory. Also, JVM will execute the code. And when JVM will execute the code, then Java interpreter come into the picture. What the Java interpreter will do? Java interpreter will take this compiled code and then it will do the conversions again. Here, the compiler converted the source code to a compiled file. Now, in this time, in here the Java interpreter will take the bytecode and read every single line and then execute it. So see, interpreter does not need to create another file because interpreter does not do it. Interpreter read every single line of the code and execute it right away on the fly. The interpreter does not need to create another file. It will read it and execute it. So Java interpreter will read the source code, okay? Java interpreter will take the compiled code, it will take it as a source code and interpret it to something the machine will understand. And in this case, this machine is the actual hardware machine that we are talking about. Okay? Something that machine will understand. This virtual machine is created through the software system that can take the resources of the actual computer, actual hardware. But again, it interprets and then it will convert it to something, some instruction that machine can understand. And then machine will take the instruction and execute it and then give you the output, whatever the output you are looking for. So this is whatever the diagram I'm showing here is also here. Same diagram, I'm just typing in, right? We're taking the source code, it will compile. Compiler, the nature of compiler is that it will compile to to a compiled file. The compiled file in Java is called a special name called bytecode, and it has a extension called .class. And this code is a machine independent. Now this code again is taken by the Java virtual machine. Java virtual machine will do some work with this file. It will do some memory allocation. It will load the file. It will then verify the code, the syntax and everything. Then it will execute the code. And when it will execute the code, it will use the help of Java interpreter. Then Java interpreter will go every single line of the code written in this bytecode, and then it will execute to something that machine can understand, and then machine will give me the output of whatever instructions I have given. Up to this point, anyone had any confusions, any questions, just let me know now.
Juel Bhai.
Yes.
I do have a question. Is how much memory JVM allocated usually, like in?
I mean, how much memory
JVM. I mean, like RAM. How much RAM JVM allocated when is running?
I mean, it depends on how much. I mean, depends on what are the data types you have in your program. What are the components you have in your code, right?
Right.
If you want to do some calculations with some numbers, if you want to do some text processing, JVM will understand. JVM will decide at that time during the runtime how much memory it will need. Now, in some advanced coding that you can allocate, you can actually mention that, okay, I can allocate some specific dedicated memory for my Java virtual machine. But you don't have to worry about it when you're running your code. For you, the Java virtual machine will take care how much memory it will need to execute or create an instance to run the code.
So it's not gonna memory overflow happening, right?
No, memory what? I'm sorry?
Overflow.
No, that thing will be handled by the Java. Java also handle the garbage collections. Java also handle the memory, right? All these things will be handled by the Java. Okay. So Java will take care of it. This is why Java has the memory allocation, memory management thing, right?
Right.
This is why Java has a different kind of memory management system. Java create some heap. Heap is a special kind of memory that Java creates. Okay. Java creates some Java PC registers.
Right.
Okay. Some different kind of memory management system Java itself can do. This is why Java virtual machine itself is called a machine. It's a virtual machine, but it can work as like the actual machine.
So I mean, when like a multi-threading happening, so JVM can allocate memory more, right?
When multi-threading happening, then Java can handle that things. When multi-threading happening, when there's something is happening simultaneously, like you want to execute one task from two different Java instances, or there is one Java instance, you want to change it simultaneously. Now Java has its own processing. The multi-threading processing, it has the own mechanism that can handle it.
Okay.
You don't have to do something like specific. Now, how you're writing code, it also depends on it.
You were saying like, sometimes we can allocate memory if we need it.
Sometimes you can, I mean, there is some advanced concept that you can allocate memory for the Java virtual machine.
Okay, thank you. Thank you, Juel.
But for your coding, the kind of coding that you do,
right,
at that point, you don't have to do it. You don't have to worry about like utilizing or converting, altering the memory. Don't even think about it. You don't have to worry about it.
All right.
For the kind of coding that you will do, it just rely on the Java virtual machine, rely on the Java system, the JDK that you will be installing, that will handle it.
All right. Thank you, Juel Bhai.
Okay, no problem. But you need to understand the Java handle those stuff.
Right.
Okay. Java handle its own. Java has its own Java virtual machine memory. Okay.
So Juel Bhai, when we say like bytecode, that means .class file, right?
.class is the bytecode. That's correct.
Okay.
Okay.
Thank you, Juel.
Good. No problem. Anyone have any other questions up to this point?
I have a question.
Is this?
Hello. Yeah, this is Zahid.
Yes, Jahid Bhai. Yes, sorry.
Yeah. So we can see that the compiler here is converting the source code to the bytecode, and within the JVM the interpreter is again converting it to machine readable code, or the interpreter is just reading the code, just identifying the code?
Good question. So here is the yes, we are converting code 2 times. First is you are actually writing the code. I mean, it will be more clear when I will be writing code, okay? But let me explain it right now. So you will be writing some code, source code. You are writing source code using the syntax or the rule the Java programming language have, okay? You are writing a code. You want to print something, or you want to do some additions of 2 numbers. 1 plus 2 is 3, right? You want to do some small calculations. Now you have written your code, right? Then you will be compiling it. When Java will compile it, Java will convert that file to another file with a .class extension. We are calling it compiled file, right? And we are calling it is a special name for bytecode. Now this compiled file, we know the nature of compiler is that it will convert the file to something that machine can understand, correct?
Yeah.
Now here, this compiled code, which machine will understand? This compiled code we are creating for Java virtual machine. That means Java virtual machine will understand this code. It's not like the regular machine. Now, if Java virtual machine can understand this code, then how about the actual machine? Actual machine.
The JVM has to execute it for the computer.
Now JVM have to execute it. When JVM going to execute it, JVM is using another concept, Java interpreter. That means this is another code. We are not calling it a source code. We are calling it what? Bytecode. But bytecode is actually again another source code for Java virtual machine. So Java virtual machine is take this bytecode and go to every single instruction. Now Java virtual machine can read the bytecode. Not other computer, not other machine.
Well said, brother. Because the bytecode is initially the source code for the JVM. Well said.
Exactly. And after that, Java virtual machine will do so many stuff. Like I told you, right? The memory allocation, the class loading. Then one of the tasks the Java virtual machine do, it will execute every single statement which is written in the bytecode to something that machine can understand. To achieve this thing, what actually you need? You need another interpreter. You need another help that can actually do the task for you. This is called Java interpreter. Java interpreter will take the instruction and convert it to something that actual machine can understand. So conversion happening twice. Here we are converting, so Java virtual machine can understand. Here the actual conversion happening that machine can understand. The actual machine can understand. So 2 things. You have the Java virtual machines and you have the real machines.
Brother, so when the JVM is working in temporary memory RAM and when it is using the permanent memory inside the ROM?
I mean,
initially,
I mean, it's not the permanent memory. Everything that you want to do, everything that we are working in a computer, we are working actually in primary memory. When we are saving something, it's going back to secondary memory, right? Like your hard drive, your file, your everything. But you want to do something. Say, if I want to delete something, if I want to write something, I mean, what is the memory location? We are doing some places, right? You see, we are working in the random access memory, which is our primary memory.
Initially, it's inside the RAM.
Exactly. Now, Java can actually access this primary memory, and inside this primary memory, it can also allocate its own memory system. It can do the management because Java have to do take the instructions, say, you have to do some calculations, right? I mean, Java have to have its own memory management system. Otherwise, there are other processes happening outside the memory, right? This memory system is not only it's not only used by the Java. If I open my task manager, you see the memory, right? You see how many applications is in this memory. Firefox, Google, Eclipse, all these things are using this memory, right? So Java should have its own memory space that it can maintain its own memory. Now again, when we will move forward, when we will learn more about Java, then we will see how it works. Like we'll be talking about the Java object, right? Then how the instance are created. Why Java is having its own memory management system, because we can have so many objects created and that should be cracked down, right? And maybe one object can discuss with, one object can communicate with another object. Maybe you change something in some code, it should be reflected to other. I mean, there are a lot of other object-oriented concepts up there, right? That could be that could be well explained, and then you'll understand why Java needs its own memory, the memory management systems, and what they're doing. So in detail, if you have to go again in deep how JVM memory works, I mean, I would say you can search online to get some ideas, but I would not say that you spend too much time on understanding those things. Just have the high level overview, get the idea that this is how it works, and that's what you need right now. Okay.
Yeah.
But the concept, this is important concept, how from source code to compile to bytecode to Java virtual machine, interpreter, and machine, how the flow is working, how the flow is happening right now. This is important. That you should have a clear idea. Anyone have any question? Thanks for your questions, but anyone have any other question? Okay, Alamgir asked the question, when you use Android system, where Java or JVM have any role? Yes, Android system system also have a JVM. Otherwise, how you are like executing all the Java code? Okay, so all those applications which are written in Java, how they are executing? You have not seen your system there are a lot of devices, they come built in JVM, right? JVM is already there. Even though if you don't have Java installed in your system, you'll see the Java is updating sometimes. It asks you for Java update. Why? Because you already have a Java virtual machine installed in your computer. Otherwise, the application that is written in Java, how your computer will be able to understand it. Okay. So there are many devices that actually have Java installed. Now there is something that I can show you. JVM supported devices. How many? Okay, list of Java virtual machine. Just the number of devices supported by JVM. There was some numbers that tell that how many, basically there are lots of devices that is supported by JVM. I think I came to the same page. Okay, I don't have the actual number right now, but there are like a lot of devices that you have right now in the daily use. They already have the Java virtual machine installed in your computers. Okay. So anyone have any question till now, up to this point, to understand this flow? Up to this point, to understand the diagram that I explained? Anyone have any question? Because we need this concept to be clear. This concept has to be clear. This is very simple. If you want to learn more deep into JVM, you can go ahead, but I would not say they spend that much of time to learn more into Java virtual machine, how the other memory, memory management things are happening. You don't need to learn it now, but this is something good to learn.
Oh, brother, it's clear.
It's clear? Okay. So then let's then move forward. So this is how the Java program works. Okay. Now, what is the next thing? Is that, let me just see this in 1 second. Also, I had one diagram here. So when I say machine instruction, see, this is the machine instruction, which is 0, 0, right? I mean, this machine 0, 0, 0, this is basically stopping the program. Okay. So this instruction is doing something else. So every instruction, the machine only understands zeros and ones. But you probably want to give instructions saying, hey, stop the program. If you want to stop it, say if you want to shut down your computer, you don't want to know how the things are happening behind the scene, right? You just want to do it. You click some button, you just execute something, and it just happened. Machine understand right away. So again, compiler, interpreter have a bigger role, an important role, how you are executing your code, how you are executing your applications from any operating systems or for any Android system, from any iOS or whatever. Okay? All right. So the next thing that I want to do is like that for Java. Okay, we need to now go back to something. We need to what Eclipse. Okay. So we learn what compiler do, what interpreter do, and what is the role of compiler for Java. What is the role of interpreter in Java? What is bytecode, and what is JVM? And JVM is a machine dependent. Bytecode and is machine independent. If you execute bytecode, if you get the bytecode in any computer system, it can execute. You can also execute it to any other operating systems different than those systems. Okay. Okay. So Java. So in Java, to write down a Java code, we are writing it in Eclipse. Anyone have any idea what is Eclipse? What is this thing? I mean, the window that I opened, right? You guys can see my window, right?
Yes.
Yes.
Anyone have any idea what it is?
It's an IDE to write Java code.
It's the Eclipse IDE.
What does it mean by IDE?
IDE, I mean, integrated development environment.
Environment. That means it's giving you some development environment that you need to develop your code, right? So
Exactly.
it's integrated. It has some smart system included in this IDE. So without IDE, can you write your code?
Yeah, we do.
No, we cannot. I mean, if we can, then those won't be this much updated like as we did in past.
I mean, you
cannot execute.
I mean, you might not be able to get the benefit the IDE can have. Okay, let me see. Let me see what we can do. Okay.
We can do like.
Let me try again in here. Let me cancel it. Let me cancel this stuff. Okay. Let me create a file here. Hold on one second. So I want to create a Java file. I am not using IDE, okay? I am not, maybe I can use this computer system. Hopefully I have everything installed here. Java C version. Okay, I have Java compiler installed. So Java C is Java compiler, right? So what I'm going to do here, let me see where I am right now. Java. I'm just trying to give you an idea that without IDE, how this thing happens. And this is important. You don't need to do it at your home, but you need to get the idea. So say, I'm just creating a file saying that, I'm going here, saying that the name of the file will be my Java. My Java file. My Java file dot Java. The Java source code should always have a what? The Java extension, right?
Right.
Okay. Okay. So I'm writing. I'm going to explain. Just see the code right now. My Java file. Service static. Right now. Okay.
The window is too small. Can you zoom it a little bit more?
There's a problem that this is a virtual computer, so I'm not able to do it. Let me see.
Okay, it's okay.
Is it better? Is it better or not?
Yeah, better. No problem.
Or is it same? Is it better?
Yes.
Yes.
Yeah, much better.
ARGS.
Okay. So this is a simple Java file. Let me see. So this is my Java file, right? This is I have written some code, and I want to just print a line called hello world. Okay. This is I'm written in a single file. The name of the file is my Java file.java. Now this is a command to compile this file, Java C my Java file.java. If everything goes well without any problem, then I should see a bytecode. What should I see the bytecode? What should be the name of the bytecode? It should have an extension .class, my Java file.class. So I have this file, right? So I was able to execute, I was able to compile the code, and I have the compiled file called my Java file.class, correct? Now, if I want to see the my Java file.class, how it looks like, I can see it. Sorry, not this one. Let's say class, right? See, so this is what? This is my bytecode. Who can understand this bytecode? Java virtual machine. Java interpreter can read this bytecode. This bytecode is machine independent. I can take it to another machine and I can execute it. Okay. Now I'm going to go out and I'm going to run this bytecode. I'm saying Java, just saying my Java file. I don't have to give .class. If I do it, I see the output hello world, right? So what just happened? I compile it. The name, the compiled file is the bytecode. It has the extension .java, like this one. My java.class, this is the compiled file, the bytecode, and I executed it using the Java command. Now Java C is the command to compile a source code, to create a bytecode, which has the extension .class. And Java, just saying Java is the command that will execute. Now, who will help me to execute this thing? Java virtual machine. Java virtual machine already installed here, so it will help me to execute this bytecode. And then Java interpreter will come into the pictures, which is also a part of Java virtual machine. It will read every single line written in that code and execute it and give me the output hello world. Just to get a hello world that you can read, I can read, everyone can read, which is simple by running the Java command, right? But if anyone, you give the file, this file, if you give this file to anyone, do you think anyone will understand? If I give this file to any one of you guys, do you think you will understand? No, you will not understand. That's not possible. Human will not understand this code. So this is why compiler interpreter is very important. Now I have written and executed this code without IDE, right? Why I need an IDE? Because the platform that IDE give me is much more clean and much more interactive, right? I can create a file, I can execute it, I can do the debugging. By the way, what does it mean by debugging? Debugging is you find the error, you find some problem, you want to find it. You want to resolve that problem, then you debug it. I mean, you have a bug in your code, you debug it, you change it, you just debug it, okay? Now, this IDE, interactive development environment, a lot of other things if I need. So when you want to develop a software or application, you need also other framework, other tools. And you will see when we do Selenium, a lot of other tools we need developed by other team, other people that we don't actually use. We just actually use those things, right? So Selenium framework, we'll be using Selenium framework developed by the Selenium people. So if you have to integrate all other things that will help you to build any applications, you can do it very easily. The management is very simple. The display and all other things are very interactive using the IDE, which is not really helpful when you want to do something in command prompt using either Linux or Windows. You can do the same thing in Windows command prompt, but which is not helpful. This is why we need integrated development environment. Is that clear?
So this is called the IDE worksheet.
This is called IDE, Eclipse IDE. Eclipse is the company that developed this IDE. What are the different kind of IDE we have? Besides IDE, besides Eclipse, we also have IntelliJ. Let me open up IntelliJ. Then I can show you what is the difference between IntelliJ and IDE. You need to know your tools very well. People who does not have the Java installed, without Java, you cannot execute Java code. You cannot do anything, right? You need the Java installed. You need the IDE installed. Okay. So this is I'm opening another IDE which is called IntelliJ. Give me 1 second. It's opening. So Eclipse is a company. Eclipse is a software company that developed this IDE, Integrated Development Environment. This is the most popular IDE right now. Now another thing which is called IntelliJ. They look like this. Okay. It's loading my projects. This is also another IDE which is getting more popular nowadays. But for our learning purpose, we'll be working with IntelliJ. Okay. Let me show you how it looks like. So it looks like this. So this is how IntelliJ looks like. This is how it looks like. But the purpose, I mean, it also has some benefits. Some people like IntelliJ, some people like Eclipse. I like Eclipse very much. IntelliJ also have some advanced feature. But if you want to do some enterprise level coding for Java, you cannot do in this community version. You need to purchase the professional version for the IntelliJ. For Eclipse, it doesn't matter. It's all free. Even if you want to do some enterprise level coding, like from server level, backend services, all those things you want to code, you can use Java Enterprise Edition. You don't need to pay any single money for that thing. But IntelliJ is also another thing good to know. Is getting very popular. Besides Eclipse and IntelliJ, there is also another popular thing that I used to use that thing in my school. That is called NetBeans. That is developed by Oracle. I'm opening up NetBeans. Eclipse is developed by Eclipse company. IntelliJ is developed by the IntelliJ IDEA company, and NetBeans is another. So NetBeans will look like this. Okay, this is developed by Oracle. Okay, this is also very popular. I remember all my projects that I did in my school. It was all in NetBeans. Okay, so but for our learning purpose in this class, you will have Eclipse, either Eclipse Java developer version or either Eclipse Java Enterprise Edition versions. 14 or 15 people, 15 students from this class does not have Eclipse. So I want you to have this Eclipse installed by next class. And you also need Java installed. JDK 8, versions 8. No need to install all the other versions. JDK 8 will do most of my work, and I want everyone to have the same versions. So since this is a remote learning, if you all have the same thing, same tool, it's good. It's easy for me to go ahead and teach you guys. Sometimes some people doesn't have the updated version, or someone have the very updated version. If some problems coming up, it will not be easy for me to go and fix that problem right away. Okay, and I will not be able to do it at the time. I will have to stop you, and I will have to tell you, hey, wait for another person, or a mentor, or Simon Bhai, or some other person to help you to fix it. So I want to avoid that kind of situation. So have Eclipse installed and Java 8 installed in your computers. I already have the list of people, and I'm going to share this thing with Simon Bhai, and he will help you guys. So this is the integrated development environment to develop any Java applications or writing any Java code. This is what you are going to have. And also you will have the Java environment setup done in your computers. Okay, this is also important. Not mandatory, but this is important. But Java installation should be done. This is important. If you don't have Java home setup done, it is still fine. It's not gonna bother you. Okay, it's not gonna give you trouble. But Java JDK 8 need to be installed. So in this Java, this is the Project Explorer. You'll be creating code. I'll show you how to do this thing. So these things, I don't need it. I can minimize. I can minimize this thing. Sometimes I've seen students, they lost everything, right? They don't have anything, blank, and they start crying. They start like, oh my God, what's happening? I don't have anything. Well, you have everything here. It's just minimizing somewhere around. Even if you close it, you can get it again back. How are you going to get it back? If you go to Windows, if you go to Show View, and I want to see console. Console is the place where you can see the output. If you click, the console coming up in here. You just have to drag it and put it here. Okay? And drag it and put it here. Okay. Maybe right here. Okay. So if you don't see it, or for some reason you lose it, don't panic. It's somewhere around here. This is the tool. You need to be very familiar with this tool. If something not you are able to find, try to look around. If you really cannot do it, Google it. If you really cannot do it, get help from your friends. If you really cannot do it, then come to me. Because this is not something that you cannot do. We have to do it. If you lose it, go to Window, Show View. It will come up in here. Because I've seen many times that it gets like, most cases, it's like minimize here, right? Like I'm minimizing. I don't like this stuff showing up in here. So most of the case, I minimize here. Okay? So if I need it, I'm going to come back here, and maybe this is not the right one. I come back here. Maybe this is not the right one. Then I'll just try to figure it out why is that one. If I really cannot find them, I'll just simply go to Window, go to Show View, Console, and I'll see them here. See? This here. Okay. So don't panic if you don't see this thing. Okay? You will always have it. So this is the tool you need to have installed. Now we'll be writing the first Java code. And a lot of things you might not understand, and I don't expect you to understand. I don't want you to just see and follow the instructions that I'm giving you right now. Just do it that much. If I have to create a Java code, if you have to write down a Java code using this integrated, the first thing is that you need to create a Java project. If you go to File, click on New, you need to create a Java project, right? Inside the Java project, we will have our Java source code. If I click in Java project, so first what I did, I went to File, I go to New, and I click on Java project. Okay. If someone have different window, it looks different, don't panic. You still go to the file, go to new. It should be file something called other or project. If you don't see Java project displaying in here, just simply go to the project. Click on project. If you click on project, just make it bigger a little more so you have more space to see. Okay. Then you will find Java here. If you have Java installed in your computer, you must see Java here. Then see the drop down. See, you also have Java project displaying in here. Some of you guys might not have displaying like the way it's displaying for me. I have the Java project right in here. You might have only project. Okay. Then you will be doing this way. You'll come to the project, you go to Java, and then you click on Java, you select Java, and then go next. Then you'll give a name of a Java project, right? So I'm just giving a simple name. I'm saying that August 2020 _ Java project. Okay. So I have Java 8 installed, so it's taking the Java runtime environment. Runtime environment basically is the environment where Java have all those built-in classes, all those built-in stuff ready, which will help you to run your Java code. So Java 2nd edition 1.8. This is the Java 8 that already I have installed. I click finish. You don't need to go back next and do this thing. No, you don't have to do it. You don't have to go next and next. No, I mean, don't need to change anything. Just give the name and click finish. That's all. So this is the folder. This folder is already created in workspace. When you open up the Eclipse, let me show you. Let me open up the Eclipse here. If I click Eclipse, it will open up the dialog box like this. It will ask you, what is the workspace? What does mean the workspace? Workspace is the place where you have all the Java code. Whatever Java code, whatever Java project you will be creating, it will be inside this workspace. Okay? Then you will be opening this workspace. Then you will get this Java window, this Eclipse window. Now I have created Java project. I want to see the locations. I can go, I can right click in here. Just I want to show you how it looks like. I right click in here. I say show in System Explorer. It will open up another window for me. See, this is my workspace. This is my workspace, Java class August 2020. In here, a project, I created a project, right? I created a project, right? August 2020 Java project. A folder is already created. What does that mean? So this folder, in this folder, some project related specific files are there. Some binary files are there. These files we need to execute our Java code, which will be running during runtime. These are called Java Runtime Environment, JRE. Okay. If you look in here, see JRE system library. See, these are the built-in code that already included in this project, Java project. Once I'm saying that I want to create a Java project, this JRE system library all added automatically. You need this code to execute your actual code. Okay. So a folder is created. A project folder is created. Inside this project folder, some important files are there. Now, all your source code, anything, see SRC means source. Anything you want to write for this project, that will be your source code. It will be in here, which is empty right now. Okay. Up to this point, any question?
No.
No? Okay. So we'll be writing our code inside this source folder. Source, right? So this is our project folder. And inside the project folder, we have another folder called source folder, SRC. All our code that we want to write, it has to be source folder. Now, before you writing code, creating any file inside the source folder, you need to create a package called Java package. Okay. This is basically why this is happening. Well, let me give you the idea. Let me just remove this stuff. Okay. The thing is that in a bigger pictures, this is your Java project. Okay. Let me write it down. This is your Java project. Okay. You created a Java project. In this Java project, you have your source folder, right? You have your source folder, which is known as SRC by default. You can change it. You can create many source folder. So by default, SRC. Now, inside this source folder, what you can do? You can create many packages. One package, two package, three. These are packages. Okay. Inside these packages, so let me write it down. Package 1, right? What I'm going to do, I'm going to, let me see if I can copy it. Nope. Okay. Package 3. This is package 4. This is package 5. This is package 6. Okay. Inside this package, you can have your actual source code. Okay. Now you can have a Java file. You can have one. Okay. Let me have another color. Let me put it different color. This one. You can have one Java file, 2, 3, 4. It might have 1 and 2. It might have 1, 2, 3. It might have 1, 2, 3, 4, 5, 6, 1. Okay. So what's happening here? You have created a Java project, right? It's a project folder. Inside the project folder, you have a source folder, which has a by default name SRC. Inside the source folder, you can create many packages. Here I have 6 packages. 1, 2, 3, 4, 5, 6. Inside the package, the packages are nothing but another folder. So this is your project folder, Java project, source folder, which is the SRC. Inside this source folder, you have 6 more folders. These are package folders. Inside the package, you have your Java files. This package has 4 files. It has 2, 3, 6, 1. It has 2 files. Why we need to have this kind of structures? Anyone? Just idea. Why do you think we need to have this kind of? Okay, let me go back. Let me ask you this. Before I ask this question, let me implement it here, right? Like I say, I can create what? I can create a package. So I can right click in here, new package. Package is package 1. Okay. New package 2. Okay. New package 3. Correct. Now inside this package, I can create a Java file. I can create. how I'm going to create a Java file? I go to package, right click, new, and I'll be create class, Java class. Okay, I'll create class. I'll be writing class 1. Okay, I'll be writing class 2. By the way, let me just, this is how you're going to change the font size. You go to window, go to preference, maximize this thing, go to general, go to appearance, okay? Then go to colors and fonts, go to basic, okay? Inside the text font, here is 10. I'm going to change it, edit it. I'm going to make it 16. Okay, apply. Okay, much better. It's much better. So I'm creating another class inside this package. New class. Okay. Okay. Now look carefully. First, I created a Java project, right? This is the biggest, this is my first folder, the project folder. Inside this project, I have a source folder already there by default, right? I can have more than one source. I can right click, I can have new, I can create source folder, but don't do it. You don't have to do it. If you want to try it, but I would say not to do it, okay? Keep this source folder. Inside this source folder, I have created how many packages? 1, 2, 3. How I created the package? Again, I right click in the source because I want to include the package inside this source, right? So I right click this source, I go new and click on package, right? I give a package name, package 1, package 2, package 3. Inside the package, every package I can create a class. Now what is class? What is this file? Now if I right click, any code you want to execute for now just understand this way. Moving forward, you learn more, then I can explain more, right? You're still learning. So for now, understand that for any code that you execute in Java, then you need to create a class file. I mean, you need to create a class. Because inside that class only you can put some code and that could be executed. So you right click in here, you go new and you create class. But this file already have extension .java by default. But when you creating this file, you need to right click, go new and click on class. You have to give the class name. You have to give the class name. Any Java code that you want to execute, it should be inside a class, inside a class. So the name of this class is class 3. The name of this class is class 2. Name of this class is class 1. You can give any name. Okay. Now what I'm trying to tell you, so these packages have, each packages have one class each, right? I can have one more class created here, saying that class 1 underscore 1 underscore 1. Okay. 1 dash will never work. I said underscore, but I gave dash, right? I did a mistake. But you have to give underscore 1, okay? So I have created another class in here, right? So how many classes I have for package 1? 2. How many classes I have for package 2? Is 1. For package 3, I have 3. So this is just why we need this many packages. Why I cannot create one package and put everything in one package. I can do it, okay? Say, I don't need it, delete it. I don't need this package, delete it. I can keep one package and I can create as many class I want to create, I can create it. I want to create class 2 here. I want to create class 3 here, right? As many class I want to create, I can create inside this package. I don't need more than one package. But again, why we need to create packages? I can create it, right? I have two options. Either I can put all the classes in one package, or I can create different packages and I can create different classes for those packages. It's about how you want to maintain your code. there are some code which are related to each other. They should go in one single package. It's like you are organizing the stuff, right? If class 1 and class 1_1, these two classes are related, I'm putting it in one single package. Say now the name of this package is, say the name of the package, say I'm going to create an application which is like a banking application, right? The name of this package is, let me refactor it, let me rename, say that login package. Login package, right? So login package has these classes. Now I need to create another, I need to write down some more code which would be related to transaction package, banking transaction, right? I'm just showing you example, trying to understand. If you don't understand, let me know. So transaction package. So I can put classes in here saying that transaction 1, transaction class 1, and create another class which is also related to transaction. I'm giving it a name transaction 2. So these two classes, these two classes means whatever coding I'll be doing, whatever code I'll be writing for transactions, I'm putting in these two classes. Since these two files, this coding are related to transactions, I'm putting them in transaction package. Now these classes, this coding, these files are related to the login, so I'm putting them in login packages. So I'm just maintaining the way the code are related in different packages, different boxes. Like the way I explained it to you, right? In this diagram, I just tried to explain it to you. If you have, this is a bigger picture. You have the project, Java project. You have the source folders, right? Now this related classes, related coding file will go in this package. These two files are related. They're going to this here. So this is might be login. This coding will be handling the login of the application. This, I mean, say for example, for some bank application, right? For some TD bank application. So this classes, this coding will handle the login part. This coding will handle the transaction part. This coding will handle the money transfer. You want to transfer money from checking to saving account. This coding will handle some other features, right? You want to pay the bill from your TD bank, that you can handle, right? You want to transfer money from the Juel or some other third party, you can do it from here. So these are all related coding, related files I'm putting in one package. For me, it's good, it's easy to maintain. Why? If I have to find which classes, which coding is related to login, I don't have to look here, right? I don't have to look in here. I don't have to look here. I can directly go in this package because I know I'm maintaining all the login related coding in this package. I don't have to change any code from any other package, for any other file. I don't even have to look into this package because they are not related to this login items, login functionality. Does it make sense? That why we have project, source, and why we have different packages? Any question?
No.
Hello? Does that make sense what I said?
Yes.
Okay. This is the architectures, how you are going to follow moving forward in this class. Even any time when you'll be at work, you'll be following this one. And this is how people follow. This is how developers develop. This is how we work. This is how you have to work too, to maintain better
brother,
management
we are
of
putting,
your coding.
brother, we are putting several packages inside a project. Whenever we will be having several projects, is there any way to keep all those projects inside a folder?
No, for project you have a different folder. Every project will be different. It's not like that. I mean, if you always want to look something to put in something else, it's not going to happen, right? If you're a Java project, project is the higher level. You cannot go higher than project. This is the topmost
Okay.
box. You cannot put this box into another box.
Okay.
Okay. What you can do, you can create some jar files. That's called Java archive. But again, Java archive file does not have the Java project. You can take many classes and you can create Java archive. Okay. So you are not putting Java project into another folder. No, you're not doing it. You cannot put one project to another project. No. One project can take the help from another project. If you have another project and you have some classes, some coding from another project, you can use them. That we will see in future. But to answer your question, no, you cannot do it. Okay? Anyone have any questions how the structure is here and how the structure should be moving forward? First, you have to create a Java project, the source folder, then you have to create a package, then inside you have to create a class. Anything you want to execute for Java, it should have a Java class. So I'm going to remove everything and I'm going to start over. Let me delete it. I'm going to close all. I'm going to delete. Okay. So I have created a Java project, right? And I want to write down my first code in Java. It will print out a string saying hello talented. To achieve this thing, what I need first? I need to write the code in some source file, right?
Yes.
So what I'm going to do, I know that all my source code will be inside this src folder, right? I right click here. First thing, I need to create a package. Now, writing package has some conventions. If you go to any company, right? Say you're working for ups.com. You know what is ups.com, right? Or maybe you're working for amazon.com. So the way the package name, the convention is that your domain name should come first. Okay? So say you are the employee of Talented. Then Talented has a domain called talented.com. Anybody who is please not talking, please mute yourself. So talented.com, the com is the domain, right? You should write something like this, com.talented. This is the convention. The com is the domain name. The com is the domain extension. This is the final domain, right? .com, .net. The actual domain name is talented. Okay. This is a root domain, like com.com. So it will be in reverse. This is the practice that people have. Okay. This is the practice that people have. Let me see if I can show you any example. In Java source, right? Let me see how they are writing their package here. This is the package. See, this is the package, right? Can you see the examples? How Java has written their code, the package name? Yes? No? Very good. Anything else? See, the com is coming first, right? com.sun.coop.se. SE for Sweden, right? So this is the extent. It's just a reverse. They're using the reverse direction, right? This is the standard way of writing package name. If you don't have anything like this, that is still fine. If you're writing down something like this, if you write down like something like this, my.java.package, it's still gonna work. Okay, you cannot write down Java package. It's a system. Java package is it's a Java reserved thing. Okay, my package. Okay, cannot write package. You have to write pack. Package is a word which is reserved by Java. You cannot do it. You can say my.java.pack. Okay. You can have a dot, or if you don't give a dot, just say my package. This is gonna work. But the reason I'm telling you, when you go to any work, right, when hundreds of people are working and following the directions, you suddenly started writing something different way, which is not feasible, right? You have to follow the rule and convention the people are already following. Okay? So for now, say talenttech.com is the company that where you are working right now. So I want to give com.talenttech. I want to give com.java.talenttech. Make sense? Because this is the convention that Java is following. Java developers are following. Instead of writing talenttech.java.com, you just reverse it. Anyone have any question to understand this? It's a very simple thing. Don't think complicated. Don't make it complicated to yourself. Is good?
Yes, good.
All right. And it has to be all small letters. This is the convention, okay? And we'll follow the convention. Now package is ready. Now I'm going to write my first Java code. If I have to write my Java code, what I need to create a class file. So not class file, I need to create a class. I need to create a Java source code. How I'm going to do it? And right click in here. I go to new and click on class. See the class? I click in class. Now you must need a class name. Inside the class, you will be writing your actual code. Without class, you cannot execute, you cannot write anything. This is by default, you need to remember for now. In future, we might see some difference, but don't worry about the future right now. For now, until I'm telling you this is what's happening, this is how it was, you must need a class. No exceptions. Without class, you cannot execute your code. Okay, this is it for now. What's going to happen in future, we'll see later. Okay? Don't change anything, just give the name, class name. Now, there is a convention for class name too, how the class name should be. The first thing is, you cannot use a digital, any number before the class name. You cannot have it. Okay? But you can have a number, any number after the letter. So I'm saying M1 or within in between some other letters or maybe after the letters. So first it should be start with a letter. It cannot start with the special characters. You cannot do it. You cannot write down a class this way. You can use any letters and then use underscore then number. You cannot use my and a special character. Not going to happen. You cannot use dash. You can use underscore, okay? And you can use numbers. This is how class name should be. All right? The first thing is what? Who can tell me? What did I say? What was the first thing, I think?
Capital.
Alphabetically, you can start it.
Yeah. I think what was the first thing for the class name?
The capital letter and let
the concern, the question answer the person I'm asking. I think what will be the first thing? Can we have letter in the class name?
Cannot start with a number.
We cannot start with the number. But can we have number after any letters? Yes. Any kind after the number.
Yes.
We can add it.
Yes.
Okay. So can we have dash?
No.
We cannot have any dash.
You can have underscore.
Underscore.
Can we start with a special character like person? We cannot.
No.
Can we have a special character after any time inside the? No, we cannot.
No.
We
cannot. Yes, we can use only underscore. We cannot use ampersand. We cannot use at the rate. We cannot use dollar. We cannot do it. Okay.
You can just use the number.
Yes, very good. Thank you so much. Okay. Another thing, it has to be camel case. This is the convention. If you don't put camel case, it's still fine. It is still fine, but I'm telling you to follow the convention, and there is a reason behind it. because by just looking into the name, anyone can say, hey, this is a class. You don't have to think much. You don't have to look into the code, right? Why people do it? Because this is the conventions, and conventions are important because most people are following these conventions. If you don't do it, only thing is that other people will not have the benefit from the naming conventions. Okay, that's not going to help others. So let's not do it. What is a camel case? Camel case means if you have two words. If I'm saying that, if I'm giving the name of the Java, I mean this Java file. This is my new Java, right? New Java class file. If I want to give a name, if I'm saying my Java file, how many words is there? How many words are there? 3 words, right? My
Java.
You cannot, yes, and Java. By the way, white space, you cannot even use white space, okay? White space is also a special character. You cannot use space. But I'm just showing you. I have three words. My Java file. So why I'm calling these words a camel case? Camel case means the first letter from the word should be capital letter.
To be capital.
So this is called camel case. I'm sorry. If I'm saying that hello world, is that a camel case word?
No.
No, right? Because
W is
W has to be capital.
Yeah.
Wonderful. This is how Java is asking
Camel
follow
case.
this convention.
How come that's not camel case? Because it's not capital W?
Sorry, what was that?
Explain again what happened with hello world and camel case.
What will happen if you don't follow the camel case?
Right. You said when you had the little W, it was not a camel case.
Yes, this is not a camel case, right?
Mm-hmm.
Do you understand why this is not a camel case?
Because it's a small W.
Exactly.
Okay, got it. Okay.
Now this is camel case.
Okay, got it.
Okay, so this is the convention Java is telling when you are writing a class name, when you're writing when you're giving a name, just use the camel case. This name would be used as the class name of your Java file. The file will also have the same name with the extension .java. Why? Because in productions, practically, when you'll be writing a lot of code, just looking into the name, people just say, oh, this is a class. We'll be learning more about methods. Methods also have a different convention. So by just looking into the small stuff, it actually saves some time, It's helpful many times. So you guys are going to follow the same conventions, okay? So I'm just giving it a name, my first Java. My first Java, okay? My first Java. And see here checkbox. There's one checkbox called public static void main. Select it. Okay? If this is selected or not selected, it's not a problem. It's fine. But keep it as it is. What's happening? Sorry. I think I just closed it. My
First Java.
first Java, okay? And what I said, what needs to be checked? Public static void main. Okay?
Public static void main.
Wonderful. And if this is selected, keep it selected. And then finish. So what does happen? So this is the beauty of IDE. Okay? Who is doing, is there anyone using XP pen or something?
Sorry?
Oh, no, I'm getting some error or something in here. Okay, it's fine. All right. So, you give me 1 second. Right. So this is the beauty for the IDE, right? So what just happened here? You created a Java file inside a package, right? And Java file must have a class. This is the syntax for creating a class. Okay. Syntax of creating a class is that you should have this keyword. You should have this keyword for class. This is a very important keyword, class. All right. Then you will have class name. Okay. This angular brackets I'm just giving to show you. Don't put the angular brackets around the class name. Okay. I'm just giving you an example. I mean, here you see, did I give angular brackets? I didn't give it, right? Don't worry about the public. Don't worry about this in public right now. But don't give like angular brackets that I gave you. Don't follow as it is literally, okay? I'm just giving an example. This is the class, is the keyword, class name is the name you're giving for the class. Then it will have curly brackets, start curly brackets and end curly brackets, right? If you want to execute something using the Java, first you need to create a Java file. Inside the Java file, you will have this class. We are calling this the class because it has a class keyword and it should be followed by a class name. Okay, and any code you want to write, you have to write inside this class. This is the first thing to do. It's not going to change. It will never change. Okay? First, you will write a class, then you will write a class name, then you will start a curly brackets and the curly brackets up to this point. Good?
Yes, sir.
Now, after this, if you want to execute something, then you need something called method. In Java, without method, you cannot execute. In Java, there could be more than one method, but there is one method, which is the main method. And if you want to execute something, it should be executed through this main method. Main method is the gateway. Without main method, you cannot execute any code. And since this is the main method, it looks different. It looks different than any other method. First of all, you need a class to write your Java code. Inside the Java code, you need a method to execute your code. And to execute your code, there should be one main method. There cannot be more than one method. There could be many methods, but there should be only one main method. Now, forget about many methods. Just think that there is only one method, which is called main. There is only one method, which is called main method, right? So this is the main. So think about the captain of the ship. Do you think the captain of the ship and the sailor in the ship, they look same? How you identify the captain of the ship? How you identify the captain of a ship?
With a hat?
Yes, with the hat. Or maybe the general of an army, right? How soldiers can identify he's the general? He has some badges, right?
Yes.
Some ranking system. So he's different. He's different. So your main method is different. Your main method should have all the title. What are the titles? Public, static. It has to be small though.
Yep.
Static, void, main. Then inside it should be a string. This square bracket. Then args. This one. Then it will start with a curly bracket and end with a curly brackets. These are the borders, okay? These are the border. That means these are the domain. That means this main method starts from here and in here. If you start a curly bracket, if you don't end the curly bracket, you'll get error.
Close.
That means this class is starting from here and from here. And inside the class, you have a main method. that start from here and end here. Now this
Right.
rank, the public, static, void, main, string, arts, that's never going to be changed. Never, never, never.
That's the main
If you have to remember it by heart, remember it. But never forget. Now I have found this publicly static void main. How? Did I write it down? I didn't do it. How did I find it? Let me check it again. How I'm going to check it again? I'm going to simply delete it. Never worry, never scared to delete anything. Delete it. Do it. Don't get scared. If you get scared, you'll never learn it.
Oh, you can.
Right click, new
class.
My
First
My
Java. First Java.
first Java.
Java.
Now,
In the down.
how did I get the public static void main?
Click
Right here.
public static.
Right there.
If I don't click this checkboard, what will happen? Finish. I
Nothing.
don't have public
Nothing.
static void main.
Now you have to type.
If I don't have public static void main, I cannot execute my code. I cannot. This class is a valid code, but I need to have a main method. Now, how I'm going to main method? If I forgot to get it in, there is a shortcut.
Can you type
Just
it?
type. Yes.
Yeah,
Just,
okay.
there is a shortcut. The shortcut, if you cannot remember, shortcut is that MAIN control space. Okay. If you give control space, for me it's showing error. So control space, then you enter, then you get public static void main. Okay. Now you have it. So no need to panic that I don't have this thing. What I'm gonna do? You're still good. Okay. There is always a way to fix the problem. So now we are good. Now we have class. Inside the class we have main method. Now we want to execute something. In Java, you want to print some line. So I want to run this code. So it will show me some output inside the console. See the console here?
Yes.
It will be output. Any output will be printed here. Yeah. So I want to print something. So print something, Java has some specific command. Okay? How to do it? It's called system.
So
dot out dot print ln. Ln means print line. Okay? And you give a parenthesis, then semicolon. Excuse me. Now I have more than one parenthesis. The parenthesis coming automatically. I'm going to remove it. Okay?
Yes.
Now.
Quick question.
Yes.
I think there is a shortcut too, right, for the system out line.
There is a shortcut. We come later for shortcut. First, we see how to type it down. Then we go into shortcut. Okay?
Yes, sir.
Because if everything is shortcut, then they will ask in interview to write it down. How are you going to write it down in shortcut? That's not going to happen, right? So sometimes when they teach programming in the school, they teach the coding by writing in a paper. Writing in a white paper, take the pencil and write your code. Don't type it in. They don't even, when I didn't learn coding in IDE because my professor didn't allow me in IDE. We have written code in a command prompt, like the way I show you, right? In the black screen. This is how we have learned. Because why? Because this is the benefit that you are getting from IDE. So people sometimes don't remember, they just can't remember, okay, what has to be done? Is that S has to be capital or smaller? Is the public should be capital or smaller? What other things should be there? Because everything you're getting automatically, right? So sometimes getting something through automatically is good, but manually it's good practice to write down your code. Because sometimes when you go to an interview, they probably will ask you, okay, write down the code in the whiteboard. How are you going to do it? Tell me. You will have no idea, nothing.
Yes, that happened with me.
Yes, I mean, it can happen with anyone, right? So let's have the practice. So this system.out.print line, this statement can help you to print any line. What if I don't give ln? It's still going to work. Okay? It's still going to work. Okay? It is still going to work. But the thing is that the input that you're giving here, it should be given under these two quotation. Two quote, right? Two quotation. So what's the difference between print and println? I'm going to tell you, but I'm going to come for this difference later. First, I'm going to write down here saying that hello talent tech. Okay, hello talent tech. Then I'm going to save this code. Okay, I'm going to save this code. Now, in IDE, unlike the other thing that we did, right? I compiled it, right, in the Java C. Remember? Then I executed with the Java command. In IDE, you are not doing it, right? This is very easy. What are you going to do? You save it. You see the play button here. Run my Java first. If I click, it will. What will happen? It will create a class file. It will compile and execute right away. All this thing will be handled by IDE. You don't have to wait for the class file. IDE will execute the Java C, and then it will run the code right away. So if I, just to show you an example, if I go to the file location, System Explorer, so you will see, let me open up. Okay, it just opened it here. Okay, you will see here, see, this is my source code, right? This is the source. Inside the source, I have the COM, Java, Talented. This is my source. Now, I don't have any class file created yet. I don't have any class file created yet. So what I'm expecting when I run the code, then class file will be created. Okay? And this class file will be created in here. Okay, you know what? It just already created a class file. As soon as I save the code, right? As soon as I save this code, Control S, this file is saved, it already compiled it. IDE is this much intelligent. It's very intelligent. You save it, it's just creating a class file. So this is the class file. This is your class file. So the thing is that, so this is the interesting thing. Let me show you one just thing. If I come in here, right? Let me show you. If I say Java and run it in here. Hold on 1 second. Let me go to this location first. The directory name is invalid. I have to go to this folder first, then cd. Give me 1 second. cd software testing training. Then 1 second. Talented. Selenium. Java workspace. Talented teaching. Talented Java class. Java August. Okay. Now CDB. CD August project. Beam. Com. Java. Talented. Okay. Now I have this my Java. Okay, let me see if I can execute from here. Okay, could not find or load main class my first Java class. Okay. It's because maybe, let me see. I'm not able to run it from here. Could not. Okay. This is a crossfire. Anyway, so this class actually, I mean, the class will actually create. Okay, let me do one. Let me run it. If I click the run, you see the hello talented already printed, right? So what just happened? When I saved the file, it created the class, and when I run it, it actually running the Java file right away. Okay, I wanted to do it from the command prompt, but didn't work. Anyway, so up to this point, did you understand what just happened here?
How did you run it?
So to run it, I click in here. Do you see the run, the green button here, small?
Yeah.
And there is a shortcut too. Shortcut is, if you are you using Windows or Mac?
Windows.
Windows.
Okay, so if you give the like a Control F11, then it will also execute. Control F11, okay? Control F11 will also execute your code. Or you can go in here, run it. Or there is run. If you go to run and say run. There's a shortcut is even given here, Control 11, it will execute it.
So for with Mac, it's gonna be command 11, right? F11.
Yeah, I mean Mac will be command CMD, right?
Mm-hmm.
Yeah, command F11. Try it. You already have Eclipse, Amiko?
No, not yet. I'll do it. No, I just bought this laptop.
Okay. What do you have now, Mac or Windows?
For me?
Yeah.
Yeah, I have a Mac. I have a Mac.
Okay, Mac. Okay, very good. So yes, so any Mac users, they can use command and F11. That should do the work. There's a shortcut for Windows, Control and F11 that will execute. Or you can click. You can go to run and click in here, or there is a green button. You can execute from here. So this will execute it. Okay, this will actually, when you're saving, it's basically compiled already. The IDE is very intelligent. It's doing this work for you. You don't have to run Java C or anything because IDE is working for you. It's helping you to compile the code. If any error is there, say I'm saying that I'm not giving anything, right? This is the error, right? So this error is already displayed in here. So this IDE is handling all this stuff. It's showing you the error mark. It's showing you if there is some problems. I mean, if I don't have the semicolon, there is the error, right? If you take the cursor, see, if you take the cursor, it will tell you syntax error. And every time you get some errors, I will suggest you read the error. In 99% cases, most problems get solved when you read into the error. It gives you the instructions in most cases. You take the cursor, it's telling me syntax error, insert semicolon to complete block statement. Okay, so I need to enter semicolon. So try to figure out all this small stuff. This is very important. When you'll be writing code, you'll be missing it, you'll be getting error. So don't get frustrated. Try to figure out, read the error first and see what's happening. And you'll be able to fix it. You'll be able to debug it, okay? So what did you learn? Class name should have a camel case. And there we must need a class to execute the Java code. To write our Java code, we need a class. Now this public, is it important? It's not important. You can take it out. If it is still here, is it bothering me? It's not bothering me. So let's not worry about it, right? Let's keep it as it is. We'll be discussing more about this public, static, void in the future classes. These concepts are important. You need to understand what does mean by these things. Every single piece you see in this code, you need to understand.
Yeah.
All right? That you're going to do. But first, we need to know how to write a Java code. What is the convention? Class name should be camel case. And I must have a class. Without class, I cannot write my code. When I have a class, then what I need a main method. Why I need main method? To execute my Java code, I need a main method. And what does Java code main method look like? It has this special thing. These are called These are called identifier. Okay, these are called Java identifier, public, static, void. All these words have a special meaning. They are also Java keyword. Okay, you cannot use this keyword anywhere you want to use, right? These are reserved for Java. Java using this keyword. These are also identifier. This is the main. This everything you see is reserved for main method. Main method or class, whatever you're writing, it should start from a curly bracket, end with a curly bracket. If you are missing curly bracket, you'll getting error. Now, to print out simple line, what have you use? System.out.print. What is the difference, or what are the different way you can print out? I can also print out. There is a shortcut. If I have now, whoever asked for the shortcut, this is a shortcut. SYSOUT. Okay, then control space. For Mac, use command space. Control space will give me the everything, right, coming up in here. Now, if I print out something, hi everyone. If I print out saving it, okay, and then I am executing these things. So see what's happening. This line printed and this line get printed next to this line. Correct? It's not like that. This is one statement, one line. This is number 8, right? And this is another statement in number 10. It's not automatically putting this line after this line. That means this string is also displaying along with this string. Why? Because when you are just saying print, it's printing, and after that is the cursor. This is the cursor, right? You see the cursor, the control? See the cursor? You see that this thing is blinking? This is called cursor, the control. The control is still in this line. It's not coming back to this line. But how about I write down something, I write down this line, I'm going to write down, print down here, and just copy it and paste here, and I'm going to execute in here. This line is coming in second line. Why? Why? Because when you have the only print, it's printing this one, the control is still in this line. When you put LN, line, LN, the line, the control is coming down to the next line. That means it's printed this line and the control coming to next line. That means this line, this string would be printed in the second line. Again, you have the LN. Again, this line will be printed and the control will come to the next line, and then this string will be printed down in the next line. That means if I execute this thing, I will see 3 different lines. And this is the first line, second line, third line. There are many times you don't want to print everything in different line. You want to print everything in one single line. Then you're going to use print, just print. If you want to use print something in one line, then you want the next line should be printed in the next line, then you should use print ln. And what is the shortcut? Again, SYSOUT, control space for Windows, command space for Mac. Any question up to this point?
No.
Okay. So I'm just telling the same thing again. To write your Java code, you must have a class. You must have a file, must have a Java file with a class. This is the class. The class starts, this is the my first Java class. What is the name of the class? My first Java. It is starting here, ending here. How can I say this is the my first Java class? Because it starts with a class identifier. Whenever you say class and you write down something, that become a class. This is a class. Inside the class, you can write Java code. Okay, you can write a Java code, but if you want to execute the Java code, what you need? Main method. How many main methods you can have inside a class? Inside one single class, you can have only one main method. You cannot have more than one main method in one single class. Okay? This is the convention. And name should be camel case. Some shortcut we learned. If you have to print out something, you need to have these things. You need to have system.out.print or print line This is called parenthesis. See, this is called parenthesis. Okay, this is called square bracket. This is this is called curly bracket. This is called square brackets. Okay, this is called angular brackets. Okay, so you need to know, you need to remember this thing. I know you already know, but I'm just refreshing it again to you, because I'm going to use this word many times. At the time, you need to catch this thing right away. No need to worry that what is parenthesis, what is this. Don't worry about it. You need to understand these things. Now, this is the parenthesis and starting and ending. And you need to have double quotation mark to print out something. If you don't give double quotation, it will throw an error. You will not be able to print it. Okay? You will not be able to print it. If any quotation, one quotation is there, one is missing, you will also get error. If you're getting error, what you're going to do, you take the cursor and you will read the error. Okay? You read the error and you will understand from this error code. Most cases, you need to have this practice. Now, this is the time to have your practice done. Because at work, you will face a lot of errors. And who are you going to ask? Your peers, your other colleagues, they're also busy at the time. You need to read the error, you need to solve it by yourself, Google it, search it, then solve it by yourself. This is how you're going to learn. Otherwise, you will never learn. This is the very simple thing that we learned today. Now, this code looks a little messy, right? Sometimes it goes like this, sometimes it might go like this. It's not a good way of writing code. It should be good indented. Indented means it should have, see, it's coming, it starts from here now. Now it's starting from here. I mean, it has to be some good structure should be there. How you are going to good structure? First thing is, right click, okay? Go to source, okay? Now click, see the format. If you click in format, it will format your code in a beautiful way, right? Even your code is not formatted, it will be formatted nicely. The curly bracket will be put in the actual place that it should. Okay, we'll see how it works nicely when you have more coding, more lines of code in your in this file, in the file. Now the shortcut is Control-Shift-F. How are you going to learn more shortcuts? You go and see the next to any command, the shortcuts are listed down. How I have learned all those things? By looking into this shortcut code, which is written next to the command, right? Control-Shift-F. If I have something, this is happening, this is a messed up, right? I say Control-Shift-F, it will fix the stuff and it looks good. Okay? See, this curly bracket starts here, it ends here. This one starts here, and then this is called indented. They're nicely indented, right? So we'll see it more. But this is the small stuff that make our life easy, make our coding more cleaning, and this is important. So what we learn how Java works, what are the compilers, what are the interpreters, and how Java compiler, interpreter, bytecode, all those things work, and what are those stuff. Okay, we have written a small Java code. What will be the convention for writing the Java class name? And we must need a class to write down our Java code. We must need a main method to execute a Java code. We can have only one main method in one single class. Okay, and the structure of writing creating folders in Eclipse or any IDE is that first you need to create a project, and then you have a source folder. Inside that you need to create a package. Package name also have some convention. It's going to start in this fashion. You need to have some domain name first, then it's just a reverse name. If your company have a like a company is like if you have talentech.com or talentech.java.com, then you have to reverse the thing. How I learn these things, because this is the convention the Java is given to us. See the convention that Java is following. In the industry, people are following the same thing. You'll be following the same thing. If you don't put com or something, it's still good. Just put a small letter for your package name. You should have a class inside the package. You can have many packages inside the source folder. I have one package, you can have more than one package. Like I explained it to you, this is how it works. Okay, you have the project, you have the source folder, and you have the packages. Inside the packages, you have the Java files. Okay, Java files means all the classes. We call it class. This is the Java class file. I mean, when I'm saying Java class file, don't think that it's a .class file. It's a Java file. I mean, this is a class file, okay? Java class. You need to create Java class inside the .java file, okay? So in this way, you can call it as a Java class. This is one Java class. Inside, there's one main method. So this is so far we covered, right? And we had a plan to do Java variable, Java data types, which we could not do. So I will keep the class up to this point. So next class, what I want from you guys, is that whatever I covered, go through it, try to have clear understanding of Java virtual machine, compiler, interpreter, bytecode, how it works for Java, how that small code, even the single printing line, how you can do it at home. If you don't have Eclipse, if you don't have JDK, Java installed, your first priority is to get it done from Talentech. Talentech will help you. I'll send a mail to Simon Bhai. He'll help you to get it done. And then when it is done, then follow the instruction from this recorded video and create a simple class and execute it. Do it. Nothing more than this. Now, the next thing, we'll be covering the Java variables, Java data type, Java operators. We'll be covering this one. After I cover this one, then I will be jumping some part of this one. So today class, I understand most of the class we discussed at the first time we introduced, we lost some time, right? So don't worry about it. We're gonna, if we need more classes for Java, we'll do it. Because one thing I believe, if you don't learn Java, if you don't have the comfortable with Java, moving forward in Selenium is a pain for everyone. So let's not have the pain, okay? And you'll be learning, you have to write code for the automation anyway. If you don't know Java, how are you gonna do it? How are you gonna write it? There's nothing you can remember by heart, right? Except that the few things I told you, that this is never going to change. So remember by heart, write it down 10 times in a paper. Never forget it, how it looks like. Okay, never forget these pictures, how this main method looks like. Okay, so next class, or let me see. So for you, I have the list of people, email address. I'm going to send out email. I'm going to create a Google Drive. And then I need to put some of you guys, all students in this batch email address. So give me some time. I'm going to do it by tomorrow or maybe at most Monday. I have some Java books that I like most. One is called Head First. I use this book in my school many times. This is the most popular book, and I like this book very much, trust me. This book has so many graphical, pictures and everything is help. But the thing is that, see the source code, compiler, how this thing works, everything is explained here. But this is a short, this is the course that we will be learning in just a few weeks. In school, people learn it in 2 or 3 semesters. So all credit goes to you guys. So I would say, if you want to read the books, you can read the books, and then don't spend much time. Just follow my instruction, because I'm going to teach you something that will need you to learn very fast. There are a lot of things you can keep it as a document, read it. It's always good to read. Reading a book, you can learn a lot of things from the book, trust me. But if you need some practical things, I would suggest, let's do one thing. Let's follow my instruction for the time being. What I'm telling you, just do it. After that, you go at some level, then use any resources you find online, because there are millions of resources online. Lots of good videos in YouTube. But for now, just follow my instruction. That will be my suggestions. Okay? So don't give your email address in here. I already have your email address. I'm going to send it over here by Tuesday. If you don't receive an email address, if anyone from this class is missing and not getting email address, contact with Simon Bhai. Because if you give me this email address, most chances are there I'd be like missing it. Okay, I already have it. Let me do one thing. Just give me 1 second. Let me explain. Then I'm going to go through the list of people that I have in my email address. So this book is good. Another book is that another book that I like most is The Thinking in Java. So these two books I'm going to share with you guys. But read it if you get time. Then the class notes, right? So class notes for Java introduction. This is the notes. This is the notes I always share with my students. My previous students also have the same notes. So because I cannot change Java, right? I can. This is the concept never going to change. It's always same. I'm going to share the same book with you guys. So this is the introduction. So I want you, when you come to the next class, understand, read the Java variables. The examples is given. Okay. What is data types from this note, right? Just read it. What are the different kind of data types that Java has? Java program, whatever I said about the class is already explained here. Just read it through. If you don't understand object, don't worry. Just read it like a novel, like a newspaper. Read it. Package, what is package? Okay, the naming convention I discussed is already explained in here. Java project, right? How are we going to do Java? The instructions are also given here, the steps. First, you need to create a project, the package, and class. Okay, the Java, my first Java program, the thing that I explained is already in here. I want you to go through it. Basic syntax, basic syntax, the case sensitivity, the basic syntax, the most students face problem. This is also I explain in here. So go through it. Okay, this is the documents I shared. I told you that my other students also have it. You can, they also use full documents. So follow this document. I'm going to share this document with you guys. Now, next thing is that what are the other documents I have? The Java operators, because this is also another thing that I was supposed to cover today, but I could not do it. So this file I'm going to share also with you. So the Java 1 and Java 2. Okay, the Java 1, Java 2 I'm going to share. Right? And Java control statement. So this 1, 2, 3, 4 I'm going to share. What I want from you guys, simply first get the access of Eclipse, Java, execute whatever I did completed. Now go through these two files, introductions and Java operators. Read it through, just like a storybook or anything. Read it, okay? Then I will cover these three things we'll be covering next class. Okay? The next class we will be having a lot of things to cover. Okay? So get prepared for next class. This is also one thing. Okay? So these are the resources you are going to follow right now. Besides that, there is also one website that I like for my students to have it, and I always tell them that this is the resource, good resource, right? This is one of my favorite website for Java. So you'll see some things like what is Java, what is the story of Java. No need to remember by heart. Read it. This is good, right? Just read it, go through it. These people have like a good contribution in the Java, right? Read about them. It's nice to know about them, right? How Java came out, right? What are the features Java has? All the basic stuff. Just read it. See this point, up to this point, up to the keyword, from what is Java to keyword, just read it. And follow the videos and then relax and then come the next class. Okay? And then we'll cover, these are the important stuff and these are really interesting stuff. The class, the data types, variables, operators, and these are the very basic. If you don't know, if the basic is not strong, it doesn't matter how big you become, you always fall down. So let's not have it, okay? So I'll be sending email, and let me do one thing, and let me just, since I told you this is a list of people that I have in here. So I have Samia, Salman, Dikesh, Shimul, Hassan, Ahad, Jahid, Juel, Ronnie, Masood, KM, Can you guys hear me? I think my call just dropped. I will keep talking. Anyone can confirm? Yeah, okay, fine. So I think most people are listed down in here, new people. Suva, I have the Suva's email. Tasneem, she didn't come here today. I have Omiko email. Okay. Habib Bhai is not in the list. Right? So
My name
Habib
is
Bhai,
spelled wrong.
Who is speaking?
Oh, Subaha. My name is spelled wrong.
Yeah. The Subha, I mean, it should be Subha. S-U-B-H-A, right? I mean,
S-U-B-A-H-A.
So you are already in my contact. Let me check it out. Why is the contact? Hold on 1 second.
It's right there. Right next to me, yeah.
Yeah. So you already Subaha, right? Okay, so you're already in here, right? You're already in my list because these are my all these students, right? So I have to create and shuffle you guys. I mean, I have to put you guys in again. So I'm going to do one thing. Yes. So I think Habib Bhai, yes, Atik, you are not in the list, right? Atik, and who is not in the list? Moket are. Okay, I cannot. Let me just take a note. Moket, Atik, Moket, and Habib Bhai, you are not here, right? MD Hassan. Okay, I'm going to add you guys over there too. Okay, I'm going to put you in my list. Let me see. So, and also Habib, right? Jahid is already here. I think rest of the guys are already here. Okay. So I took a note for Atik, Mokit, and the Habib. Okay, I'm going to put you guys in the list. All right. So I think that will be all for today's class. Any question?
Thank you.
No, thank
Anyone?
you.
No, thank you.
So do one thing. I mean, whatever I said, just follow it. Be relaxed. Wait for my mail, and most importantly, get the eclipse and the ID. Okay. This is the most important things to have. Okay?
Am I gonna get the recording of this class? Are we gonna get the recording?
Yes, the recording of the class would be available. I think Simon Bhai would be able to share the recording.
Okay, perfect.
Of that class. Okay. So you'll be getting the recording of this class. Okay. Thank you so much for today's class.
Thank you so much.